Yes, sir, we are live now. We are live.
Mr. Chairman, today's invited speaker, ladies and gentlemen, I welcome you all for an exciting session on ocean engineering and technology of Osicon 2021. I am Pramod Maurya, and along with my colleague Dr. Arnab Mukherjee as a coordinator, will be helping you all the participants, for smooth and hassle-free presentation. There are 7 15-minute each presentation in this session and 4 quick 5-minute each oral presentation in this session. I would now like to start our session by an introduction to the session chairman. It is a great honor and pleasure for me to introduce to you Dr. Atmanand. Dr. Atmanand is a former director of National Institute of Ocean Technology, Chennai. He has 34 years of experience in this field, and he is currently working as a visiting professor at IIT Madras. He has been pioneer in the area of deep sea technology in India. He and his team has developed in situ soil testing at the depth of, which is tested at the depth of 5,200 meters in Central Indian Ocean Basin. Dr. Atmanand has taken this challenge further to design and implement a world-class remotely operable ROV that can be used for assisting mining operation at gas hydrate sites for validation of presence of methane, pipeline inspection, etc. And that work is now being going further when we are exploiting these minerals in Indian Ocean. It was under his supervision that India's first polar water mooring observatory and a polar remotely operable vehicle was also developed. The mooring was established at Kongsbergen in Arctic region, whereas polar ROV was tested successfully at Priyadarshini Lake at Antarctica. This was first time in India we attempted a testing of a remotely operable vehicle under the ice in Antarctica. He has also guided various indigenous programs for ocean observation and underwater system, including he has been chairman and members for many steering committees, including the one which at an IO development of an underwater vehicle. He received various awards for his outstanding contribution for science and technology, like Ocean Mining Symposium Award, National Geoscience Award, Presidential Award from Institute of Electrical and Electronics Engineering, National Societal Innovation Award, and MOES National Awards of Excellence. He is a source of inspiration to all of us who wants to take ocean engineering and technology to a greater height in our country. With these words, I would like to hand over the platform to Dr. Atmanand and request him to introduce to our invited speaker and start the session. Dr. Atmanand.
Thank you very much, Dr. Pramod, for an extensive introduction. It's a pleasure to be here to chair this session on ocean technology, which is dear to my heart. And all the more, I am quite happy to introduce my former colleague and dear friend, Dr. Ramanamurthy. I would like to, I know much more than what is written here about Dr. Ramanamurthy, so I may not really go exactly like this. He did his master's and a PhD from IIT Madras, and he has been a real engineer right from the beginning when he started his Visakhapatnam Port Trust. He was a scientist at ICPAM, and he has rose to the position of director of the institute, which is now renamed as National Center for Coastal Research. He is a real ocean engineer in the real meaning of that word, because he has taken up a lot of projects which are really, really difficult to set up due to the various ocean conditions, the other infrastructure limitations, etc. One of which is the establishment of desalination plant at Lakshadweep, wherein the most difficult part of setting up some footings at the desalination plant bridge at the Agati Island was done by him under his supervision. He has also done a lot of work in setting up the tsunami model for early warning system at INCOIS, And the beach restoration at Pondicherry and Kadalur, Periyakuppam in Tamil Nadu are really a feast to your eyes if you go to that location. The major project in Gulf of Kutch, wherein a dam is to be established, is really being done under his supervision. And a lot of other projects like shoreline management, inlet management plans for coastal states and various states he has been done by him. He is a much sought after ocean engineer by many of the coastal states to protect their coasts. He was a member of the Research Advisory Committee for NSES and CMLRE, and he's also research advisor for various professional societies. And I would now request Dr. Ramanamurthy to give his invited talk. Thank you. Over to Dr. Ramanamurthy.
Thank you, Chairman, for affectionate introduction. In fact, I started my career in ICMAM, but you see, in the overall with whom I worked is, I think Dr. Atman was my mentor, and then I have done many projects with Dr. Atman. In fact, the project which he was mentioned, most of the projects I was associated with him, and then under his guidance, I could able to do. And then other two members, Dr. Shanai and then Dr. Rajivan and Dr. Sailesh Naik, with whom a lot of research has been done on that. So with few introduction, I thank Osicon President Dr. M. Ravichandran and Dr. Maurya and others for giving me this opportunity. So I will quickly go into my presentation because the time allotted is 25 minutes for that. So once again, I thank Chairman and then this organizer for good introduction and also providing me this opportunity. Is my presentation is visible?
Yes, but you can put, okay, now it is full screen. Yes, please go ahead.
So the title of the today's talk is on the recent trends in coastal research and sustainable coastal technologies. So basically, I'll be talking mostly the work which was done at NCCR on the first part, but the sustainable coastal technologies is basically from the NIOT, because I had almost last 12 years working with NIOT on the ocean technologies. My outline of presentation is on important of the coastal areas, basically threats and then challenges, which is very important. We all know IPCC report is already out. We know what are the challenges that we are going to face in coastal areas. Coastal research, what is the need? I'll be talking more on the little bit on the pollution, basically even decade of ocean science, which is very important for us in the future. Conservation of ecosystem is very important topic. What need to be done, especially for the many of the students or new researchers, what to be done, and then what are all the opportunities which are available for the future. Second one is on the coastal hazards. Extensive work has been done by the NCCR on flooding and coastal erosion, but of course, I used to work with NIOT also on the coastal erosion. What we need to do is how do we adapt to the climate change. Then last one is about sustainable technology, brief on water energy. That's what Chairman was mentioning about what work has been done by NIOT on the water and energy. The importance of coastal zone, many of us know it is a livelihood for many of the coastal population, important backbone for the local economy. Industry and tourism are the one of the two major sectors. There are many other sectors in the coast areas. Rich in biodiversity and source of the protein like fish and all, we depend for the food in the coastal areas, transportation, navigation, of course, settlements and housing, and then it got rich in the natural resources. When we look at the Indian coast, we have on the top, I have listed about what are all the economic activities we have on that, like ports and harbors, fisheries, coastal industry, power plant, renewable energy, and other side, tourism, and then various activities. When we look at the natural resources, we have wetlands, estuaries, lagoons, and mangrove areas, and same time coral reef, and then we have a marine protected areas on the system. Total, we have 9 coastal states and 4 union territories which are to be protected or conserved for the next generation. Coming to the challenges along the coast, we have high population density. Almost 30 to 40% of the people live along the coastal areas. That's why we need to balance the development and then ecosystem parallelly. We have a conflicting interest from the various stakeholders, industry, government, and then fishermen, and then non-governmental organizations. Many threats to biological diversity, especially the marine pollution. And then recently, we have risk from the climate change, especially I'll be talking more on the coastal erosion and the flooding. Marine pollution is a cause of concern. If you see on the past, we have undisturbed coastal system, which has pristine, but now with the development, we have a disturbed coastal system, eutrophication, algal blooms, which I'm shown on the right-hand side, marine litter, and oil spill, and various activities which are really a cause of concern once we come to the coastal areas. NCCR, it is a Department of Ocean Development, has initiated a program of water quality monitoring all along the coast. This is one of the database which is available within the country, where many institutes are involved. National Institute of Oceanography or even other academic universities are involved as a part of this endeavor. So what has happened is last 25 years data, now it has gone to the sustainable development goals, basically on the two areas. One is on the defining health index of the coastal areas, but a lot more to be done in this area because understanding of the coastal water is very complex. It is not that easy to understand for that. So we have many new research areas to be adopted or to work on that further. Same thing on the ocean acidification is one of the important area to be addressed for the future researchers. Once if it becomes more and more acidic, this ecosystems are subjected to the threats for that. So we have deployed a lot of water quality buoys all along the coastal areas. Right now, 3 buoys are operational, but INCOIS and then NCCR will be putting up more buoys to see not only the anthropogenic activities, mostly on the what happens to the climate change and related things on the coastal areas, what impact it has on the system. This shows the typical water quality buoy which was deployed recently off Pondicherry with various sensors. The quality data is very important when we see climate change to be addressed for that. We are talking about the numbers on the second decimal place or third decimal place. So this clearly indicates what kind of accurate data we require when we wanted to monitor along the coastal area. Same time, if we want to protect the coastal areas, we need to understand about what kind of standards we have to develop when we dispose some of the effluents into the coastal areas. That has been done by NCCR in association with the Ministry of Environment, Forest and Climate Change. This notification is already at the final stage to be published for that. Marine litter and marine plastic is much talked about in the recent date. In Government of India is now banning single-use plastic. This requires research as well as behavioral change in the public, and then lot of inputs are required from the especially on the young generation, school children. That many campaigns have been conducted all along the coastline, which shows how marine litter can cause a problem to the human health as well as the ecosystem. Especially when this marine litter enters into the ocean, it is consumed by the fish and other organisms that will again come back to the human being, and then it will greatly impact human health of the system for that. Now, straight away I come to the coastal hazard. This is latest or current topic of the system. We have IPCC report out. We all know changing climate is causing a extreme precipitation in short duration. Earlier, the same amount of rainfall which used to be distributed over a period of time, but now entire precipitation comes only in the short duration. What are all these consequences? Two things. First of all, we are not prepared ourselves for the flooding when we have a precipitation coming up in the short duration. Second one is water problem. Suppose if the entire water mass which comes only in the particular direction, it drains into the sea, we don't have water for the drinking. So we have a twofold problems from the extreme events when it causes along the Indian coast. And I have listed here some of the many coastal floods which has happened even in inland at many places, and then people are really subjected to the threat, and then are we really prepared for that? Coming to this graph shows in the recent data in July, September 2020, you can see here on the bottom, almost some 6 to 10 hours entire rainfall of 40 centimeters has occurred. That was a real problem in Mumbai many of the areas are getting flooded, and then when it happens in high tide, the water will not recede into the sea. Then entire city is subject to the lot of difficult situation for them. So we all know to either it is Mumbai or Chennai or many places. I think that IPCC report also says many of the coastal areas are subject to the climate change impact in the future for that. So we need to have a system to monitor and then really to disseminate the flood warning to the public, what happens here. And also same time, which is very important to see how we can store this water and then use it for the benefit of the population. This shows the flood in the Kerala before and after. You can see how it has impacted. And of course, this is also one of the things which need to be understood very clearly is some of the floodplains of the rivers have been occupied by the our own population, because we need to leave for that, but it has its own consequences on the flooding for that. Similarly, the case of Chennai, in fact, we started the flood warning with Chennai. In the month of 2015, I have listed here, whereas in 8 to 10, we have 25 centimeter rainfall. In the November, December, we have 40 centimeter. In other time, 33 centimeters. That means these kind of extreme events are quite common. We don't know really when it will occur, whether it will occur in this year or next year, but we have to prepare ourselves for these kind of events when we do for that. And what to be done for that? So we have developed a model integrated flood warning system. It starts from the dam and then again upstream catchment. This is what I have listed here: upstream hydrology in terms of watershed and moisture, river flood discharge, and then we need to analyze all the cross section of the river. Finally, we come to the urban area, which is going to be flooded for that, where topography and stormwater drains are very important. When we have it is connected to the sea, we also need to consider the cyclone and then sea level rise and then tides when it comes to the coastal areas for that. This is a complete modular structure which was developed for Chennai. It has been upgraded for Mumbai. Now it can be applied for either in the coastal areas or even the inland. Suppose if we have an inland, we remove the ocean part and then do the other part for that. So that's how this model is flexible for the its application to whether it is inland and the coastal area. This shows the what kind of data which goes into the system for that. First one is the exposure data, population and socioeconomics. Then we have hydrodynamic data, hydrological data, which comes from the upstream catchment, meteorological data. This data, especially MOS institute like NCMR, WF, IMD, and then IITM does do a lot of research on these areas, and then that data will directly come into the flood warning system for them. Last but not the least, the spatial data on the elevation, bathymetry, land use, land cover, and all those things will form a part of the system for that. Now I'm coming to the, this is not my domain. It is basically NCMR WF is working on the precipitation forecast for the many areas. Of course, we all know tropical climate is very difficult to predict for that, but a lot of improvement has done in the Ministry of Earth Sciences through these three institutes: IITM, Institute of Tropical Meteorology, and then Indian Meteorological Department, and National Center for Medium Weather Range Forecast. Maybe in another a couple of years, we will come out with a very high resolution and then accurate models on the coastal areas to be forecasted for that. This shows the forecasting system which works for that. We have initially aimed at 72 hours forecast, but we all know when it comes to the local area, there are a lot of uncertainties in the prediction of precipitation. That's why we are working on the forecasting tools like artificial intelligence and then deep learning techniques to see, can we give nowcast in 3 to 6 hours in more accurate way. That has been attempted for the Mumbai, and most probably I think next year we will be ready with this kind of system in the Mumbai. Inundation module, these are all very much no uncertainties are there on the system. When we see uncertainties only on the precipitation, but on the other side, we have almost crossed all the hurdles and then come to the stage accurately we can predict the inundation along the many of the coastal cities for that. Of course, one thing which is always uncertain is the drainage network, and then if there are any changes in the urban areas, that need to be incorporated in the numerical model so that the predictions are accurate for them. This shows the recent Takoti cyclone using automatic weather station. The data was collected, and we try to validate and see how this model matches well with the whatever we have predicted from it. It shows a very good matching with the system for that. Finally, we have a end-to-end system which is ready for the Mumbai. Now it has been put in operational mode at Mumbai. We are working closely with the Mumbai Municipal Corporation, and they are quite happy with that. And then, in fact, they give a lot of input to us how we should improve the system further for other cities further. When we see the monsoon 2020, what kind of predictions we did from the model and then how it matches with that. It shows a pretty good matching in terms of inundation of that area, except precipitation, that we are improving the future system for that. Now coming to the IPCC report. Suppose if you see a Mumbai city for a 1 meter storm surge or 1.5, how the city can influence. You can see here this blue pinch, which clearly indicates once there is an increase in the surge height or sea level rise, what are all the areas which are likely to be inundated. This is what is expected from the decision makers and also from the other people when we want to do for the climate change impacts on the coast further. Either it can be tsunami. This is the picture which was taken during the tsunami 2004, just before the tsunami and after tsunami, what kind of impact it can on urban floods in the Mumbai and Chennai. If we have a sea level rise, most of the deltas are subjected to the flooding that need to be really analyzed further. Over and above, if we have a storm surge, then it will be more serious further. Then we had developed already 2 flood warning systems, and now we are going to develop for Calcutta also. It is almost, it has started, and then most probably by next year, this also will be ready for that. Now coming to the flood warning region, what we need to, what this model can do. It can predict rainfall, riverbank breach, storm surge, obstruction of the flow by the roads and railways, and impact of tides and rivers and all. Finally, this model not only can be used for flood warning, but also can be used to improve our situation within the cities in terms of river draining or improvement of stormwater drain, location of pumping station to pump the water during a high flood, and also if they have a lock dates, that also can be analyzed from the system. Coming to the climate change and urban flood challenges, we need to see what are the changes which are happening in the catchment area, improving the storage of reservoirs, improving the riverbank improvement, river desiltation, coastal barriers, and advanced drainage network, and elevating low-lying areas and buildings. And then whenever we define a hazard line for that, that also will be done further. Then all this information will help us in how to make investment for the future. Suppose if we want to prepare ourselves for the climate change. Now I come to the second important hazard, which is called the coastal erosion, which is quite significant at many places of the country. Especially this magnitude has increased tremendously from 2007 onwards due to various reasons, which I'll explain in the subsequent slide. Same thing is with the coastal flooding. When we see the Kerala, one analysis which we have done recently for the Chalanam, the wave height has increased, wave speed is a little bit changed, but wave direction has changed. This has resulted in a complete change in the hydrography of the coastal system in the Kerala. Then similarly, when we start analyzing for the Arabian Sea, the number of severe cyclones have more or less increased, but more what is increased more is depressions. Because there are frequent depressions in the Arabian Sea, that has caused a coastal erosion problem as increase in magnitude compared to the other thing for that. Of course, we don't have much problem for the cyclonic storm, which is almost flat, but depressions and then severe cyclonic storms have increased in the Arabian Sea. That is really causing a problem to the coastal areas in terms of sea erosion or flooding for that. And then we all know coastal erosion is caused by natural as well as man-made, but climate change plays a significant role for that. We need to understand coastal process, so using a proper scientific data to analyze the coastal erosion and then plan for the mitigation measure for that. This shows the shoreline change map, which was prepared by NCCR using a 27 years data. Now, state-wise coastal erosion, what are all the areas which are getting eroded and then which are recreating or even in the stable, that has been defined, and this report is available in the NCCR website, which can be used by anyone. And then in fact, some of the researchers or students who wanted to work on this area, there are a lot of opportunity for that. Coming to the coastal protection, that's what Dr. Chairman was, I think, talking about that. Suppose if we don't have a problem, let us not go with the hard solutions. That's what we have done in one place in Orissa, which is pristine environment. We have not done any hard interventions or any intervention, only a simple management solution was suggested. But whereas in Pondicherry and Kadalur Perikuppam, we have to do some intervention, but that is also based on the sand-based or natural solution for that. But in places where the city is completely with huge habitation and then habitat has to be protected, then we need to have a hard solution for it. These are all the some of the hard solutions like revetment, seawalls, grinds, software breakwaters, submerged breakwaters, and thing can be used in many of the parts of the coast for that. This is Ramayapatnam, which river is getting changed due to the upstream change in the discharge. So what we have done is we have told them where we have to open the inlet. So this is just before the opening of the inlet, how the coastline was eroded completely and damaged. After opening of the mouth, you can see a beach here, and then this problem was fixed. So that's how we need to understand the process, and then without much of hard intervention, we can take care of these things. Similarly, when we come to the coastal areas, always it is better to learn something from the nature-based system. For that, Lakshadweep is protected by the waves because of the huge lagoon. They have a coral reef edge on the top, and then once the wave comes from the west coast or western side, these waves will break on the top, and then that's how these islands are protected. Same concept has been used for the Kadalur Perikuppam, a fishing village which was subjected to severe erosion, and then we have put a geotextile tube little bit of offshore 150 meters from the coast at a water depth of 4 meters. That was basically to break the waves only during the cyclonic storms. Other time, the sand is naturally moved from north to south or south to north, so that you have a good formation of beach, and then fishermen uses this particular beach for the operation of their beechcraft. Similarly, when we come to the Pondicherry, in mid-century, we used to have wide beach, but before construction of harbor, we have a beach. Now, after construction, this entire beach has lost, both due to the natural as well as man-made activities. When we look at to fixing the problem, we understand what is the impact of port, what are the impacts of the natural process which are there in the system. These was analyzed. The concept which was there in the west coast of 2 headlands and the bay was adopted, and then it was implemented in the site. This particular reef structure was designed and implemented by NIOT, which is having a weight of 900 metric tons, which was launched without any heavy equipment into the sea. That shows the capability of the institute to design and implement. For the entire project cost is only 22 crores. We could able to do the coastal protection in that area. Of course, there is a lot of learning how we design and then implement at the site for that. This shows the beach before and then after, how the people are enjoying the beach in the Pondicherry. It not only protects the coast, but also it gives a good recreation facility for the system. Not only it protects the coast, but also it gives a good ecological value in terms of now people started catching all these crabs and then fish in this area after implementation of this particular reef for that. Once we implement the second part of the reef, then we will have a complete beach both in north and south, and then city will have a permanent beach along the Pondicherry coast. Now I will show you a recent picture which was taken 2 weeks back, before and after implementation of beach nourishment. You can see a clear beach which was formed there. People always used to ask, is it really possible? But it was done at Pondicherry, and then we should go for such kind of solutions all along the coast. It is not that we are going to invest any additional extra cost for that. Whatever we are going to dredge the sand from the harbor, instead of putting in the deep sea, we started putting it in the coastline, so that your coast is protected, and then you have a recreation value for the beach. Hydrological change, I have already talked about storm surge and cyclones and all related things. We need to prepare ourselves for that. Sea level rise is one of the important concerns for the future, which was also talked about IPCC. Now, this is the case of combination of both waves as well as sea level rise in the system for that and Chalanam coast. So this shows the once we have a sea level rise of 1 meter or 2 meter, what are all the areas which are getting inundated all along the coastline is shown at this particular place. And then if you want to fix for that, there are methods to fix for that, like sandy shores or coastal structures or vegetation coast. And then finally, we need to do a little bit of more analysis of joint probability of wave and water level. Water level alone will not be sufficient, because Chalanam case has clearly shown a indication that you need to analyze both water level and then wave. There are various options like a concept of living shoreline, which has been attempted in other countries, but same thing can be adopted in India also. This shows the coast of Chalanam, which was analyzed in detail, and then all the causes for the coastal erosion was analyzed in terms of cyclones and wave activity. And finally, we have come out with a system what need to be done for it. Whenever we do such kind of sea level analysis, benchmarking of the sea level is very important. This is what need to be done if you want to protect our coast, or even you want to analyze the data. Analysis of data is very important. So now this is the important picture. I would like to draw attention of all youngsters. Suppose if you want to analyze for the coast, first we have a sea level rise. It can be 0.3 or 0.4. Tidal range is coming on the top. There is a seasonal effect which was monitored from the tide gauges which are deployed in Agatti and other places. there could be an increase in the water level by 0 to 0.3 meters, especially during the weather event. Now coming to the storm surge, and finally wave setup, and then swash which is coming to the system. All these things are all compounded effects of the coastal erosion which is coming along the coast, which need to be accounted, and then a lot of observations and data is required for doing such kind of analysis for that. Of course, we have various management strategies, whether it be the less development or moderate development or fully developed areas. Depending on that, we can have our own options what need to be done for that. But as far as possible, better to work with the nature for that. Then climate change, we need to prepare ourselves for the impacts and then risks and all those things. This shows the biophysical vulnerability in terms of increasing the resilience of the coast by improving the vegetation and all these things on the other side for that. Then these kind of maps have to be prepared for the country if we want to prepare ourselves for the climate change. This is the done for Tamil Nadu, but same thing can be done for the other parts of the coast for that. Here I would like to say NCPR, since the Osicon is conducted in NCPR, when along with NCPR and NIOT and NCCR, we are going to conduct a shallow water bathymetry for the entire coastline of India up to 30-meter water depth, which is important for the disaster management in the future for that. Of course, it is done by NIO in the west coast, but in the east coast, most of the thing was done by NIOT, and then some nearshore bathymetry will be taken up by the NCCR. This shows there are now latest techniques available to collect the bathymetry on the fast track mode with high resolution using a aerial survey that is also being attempted for the collection of bathymetry. This shows some of the bathymetry data which was collected by NIOT along the east coast of India, also in the islands using the coastal research vessels of the NIOT for the islands. Now coming to the my last part of the concluding part of that, what need to be done, suppose if you want to manage the coastal areas. Now the concept of marine spatial planning, which has come to improve the whether we can call it as a blue economy or marine spatial planning. What we are going to do is we are going to allocate the space in the ocean with a definite understanding. The principles of that one is development is important, but at the same time we have to conserve and protect the ecosystem. That's how this marine spatial planning plays a important role. This is a one step ahead of ICZM planning, which was done only on the coastal area, but we'll be doing more on the waterfront side for that. This shows the different concepts which has been done for that, and then we have taken two pilot areas, one in Lakshadweep and another one is Pondicherry, because a lot of information is already available for that. Using this, we will develop the framework which can be utilized for the future for that. This shows when we do marine spatial planning, we can also protect the coral reefs and then see restoration methods which can be done on the many parts of the coast. This particular work is done by NCCR in Gulf of Mannar or even in the Lakshadweep Islands for that. This shows the what kind of data which goes into the system in terms of field observation, modeling and mapping and spatial analysis. And finally, this plan will be implementable plan by the people for the sustainable development or blue economy for that. My last two slides, I think I will conclude. I think I am almost nearing to the time. So this is what chairman was telling about the desalination plant, which was done by through NIOT. In fact, we started this, I think I started with Dr. Atmanand only. We have commissioned 3 plants. Now 6 more plants are already the pipeline. Maybe next year it will be run. The advantage of this one is a simple technology and then easy to operate, environmentally friendly. There is no brine. In fact, if you want to do a development along the coastline, we need to really develop a desalination technology which is environmentally friendly for that. That is our future goal for that. This shows the number of the plants which will be established in Lakshadweep. Same thing, the offshore wind energy is one of the important area which was done through NIOT. Now we have a huge potential of Gujarat 36 gigawatt and 25 gigawatt in Tamil Nadu. This shows the what kind of information which goes into that. In this particular endeavor, both NIOT and then NIO is also part of that. Finally, we have designed all the structures in-house within the NIOT, and then this has implemented the site at 2 platforms in the system. This will really pave a path to the future offshore development, offshore wind projects in the country. That's all from my side. I think thank you once again, all participants and then organizers and then NCPR, Osicon for giving me this opportunity. Thank you.
Thank you very much, Dr. Ramanamurthy, for the excellent presentation, which has been, which has covered many facets of ocean engineering in the country. I would like to thank you for giving such a lucid presentation. let me also tell at this point in time that there is a conference called IEEE MTS Oceans 2022 conference that is coming up in February next year, and it is available in the website. You can see the website. OSI, Ocean Society of India, is also a technical co-sponsor. I would request all of you to send abstracts for that conference and make it a grand success. This is the first time that such a large event is going to happen in India. Now, with this, we come to the end of this part of invited speakers. Now we will move to the speakers, the general sessions. So we start with the first presentation is on performance of sea profiler during the sea trial. The presentation is by Mr. V. Gautaman. Mr. Gautaman, you are ready? Gautaman, I see he has joined. Are you there, Mr. Gautaman? Yes, Gautaman, you can start your presentation now. You can come online. I mean, you can show your video also, so that it would be good. Gautaman, you are able to listen? Looks to be some problem with Gautaman. Gautaman, can you hear? Maybe what we will do is we will not spend more time. We'll come back later on. I would request the organizers to check what is the problem with his presentation. Looks to be is not able to come online. So we'll go to the next presentation. This is by numerical study of wave transmission and interaction with submerged artificial reef at Puducherry coast. This presentation is by Mr. Alluri Satyakiran Raju. Satyakiran Raju, you can start your presentation. You are ready?
Yes, sir, I am ready, sir.
Please. Arnab, you want to tell something? Please go ahead.
Has come. This is Alluri. Okay.
Yes,
Yeah,
sir,
please go ahead. Alluri. Yeah, go ahead.
I hope I am audible and my presentation is visible.
Yeah, you are audible.
It is all fine. Please go ahead.
Thank you very much. Myself, Kiran Raju Alluri. I am working as scientist at National Center for Coastal Research. The topic which I am going to present is numerical studies of wave transformation and interaction with submerged reef at Puducherry coast. Just before going into the details of the study, first I would like to just give a background on how this project, why we are taking up this particular study. Pondicherry is a town, coastal town, which is located along at the east coast of India, and this particular coast has been undergoing severe erosion due to natural and anthropogenic activities. So to restore the beach at this location, they have gone for a solution called wedge-shaped reef. You can see the wedge-shaped reef here. And this particular reef has been fabricated on the shore. Then it is launched into the sea using airbags. Then it is actually a floating body. So it have towed it to the required location here, and they have ballasted it. Finally, this is the final location where the reef has been there. You will not be able to see it clearly, but you can see that there is some disturbances in the water where the reef is actually located. So post the construction of the reef, there is a beach formation at this particular coast. Now, if you see this particular reef and this particular image, you are seeing the depth contours here. When you see the depth contours at the reef, because of its shape, you will be able to see the contours in the V shape, which makes the bathymetry very complex over the reef simulation when you are doing that. Going a little bit into what this reef looks like, this reef is like 50 meters wide, 60 meters long, and 2.5 meters height. And this top yellow part is at a flat, which is at 2.5 meters height above the ground level. And from here to the end of the reef, slope, mild slope has been given to the system. So it will almost look like a wedge, which has two triangles, one triangle yellow color in the top and bottom triangle at the bottom. These two are connected using the slope. So this shows how complex the terrain is going to be when it is placed inside the sea. Apart from that, as it is going to sit in the bathymetry, you have the different contours of the bathymetry also, which is going to make the system further complex. Along with this, the system is designed in such a way that the top yellow part, that is the crust of the reef, is located at the charted datum. So charted data means when you are at the lowest tide level, the yellow color part is exactly going to be with the water level. So when the wave is coming onto the reef, you will have breaking as well as run up. And during the high tide, what happens is you will have the wave just propagating over the reef without getting much disturbance. All the small waves below 1 meter will be just propagating over the reef without any much disturbances happening to the actual condition. So this shows that how complex it is in the terms of behavior at different water levels. Why this has been done, like keeping the crust level at 0 meter CD, is we don't want to allow the sediment transport during the low tide. And during high tide, we want to allow the sediment to bypass the system. That is the reason you will be able to see reef, you will be able to see beach on the either side of the reef. So this makes it further complex to understand how the wave is going to propagate, then it is going to break, and it is going to run up. If you want to see all these kind of phenomena in this complex environment, conventional 2D models, which are depth averaged models, will not be able to directly understand this, because the wave breaking and run up in these models is treated mostly using an empirical relations. That is the reason why we are getting into a 3D model. So before getting into complete 3D model, we have taken a transit for a 2D model. That is what I'm going to present here. So for that, we have gone for a computational fluid dynamics tools. For this, we have used open source code called OpenForm, where we are trying to get the wave transformation, interaction, breaking, and run up also. Now, when you go for CFD, you have two options. You can go for a laminar flow or a turbulent flow. But if you see this particular reef, you will be seeing a lot of breaking that is happening. So it will be turbulent in nature. So you need to implement a turbulent model for this. When you go for a turbulence model, you have different models in the turbulence, like Reynolds average stroke models, large eddy simulations, or DNS. But the latter two, like large eddy simulations, LES and DNS, if you want to implement for this kind of scale models, it is very computationally intensive, and you cannot be able to do at right now with the available computational facilities for these scaled models. So we have tried with we try to test three RANS based models. That is K epsilon model with a single flow phase, K epsilon model with multi-phase flow, and buoyant model with KW model, K omega model. Now, before getting into this, has any studies been there previously by using these models? Yes, there are some studies available. In one of the study, they have tried to model the wave forces on a monopile, but the monopile comes mostly in a Morrison regime. They have also seen the wave breaking on a flat bed with mild slope at the end. That also they have studied. These are the two studies which are available, but no one has tried on a large structure like reef, where you have where it will be coming in diffraction as well as the reflection regimes will be coming into the picture, as well as you are going to implement the actual bathymetry in front of the reef. So this kind of problem has not been tested. So we thought of testing this particular model by using these three RANS based models. Now, before getting into modeling, how does the model solve is conventional CFD tool models solves two basic equations. One is momentum equation and second one is the continuity equation. If you see the momentum equation, you have the acceleration terms on the left side, then you have a pressure term, then you have viscous terms, and finally gravity terms. This is a conventional model, but as we are solving a problem in which you have water as well as air, especially when the wave is breaking, the interaction between water and air is going to be very complex. For this, we need to go for a multi-phase models where you have two different fluids of different density. For this, we employ volume of the fluid. This will be helpful in reconstructing the interface between the two fluids. For this, we use an additional term called as volume fraction alpha. Alpha is nothing but it is the volume of the water in the cell to the total volume of the cell. So if you take a cell like bottom one where you have water, the ratio is going to be 1, because entirely it is going to be filled with water. And the second one is, if you take the air, there the volume fraction will be 0. If you take anywhere in between interface, the fraction will be varying from 0 to 1. So once you get the volume fraction, then you will be able to calculate the density by using the volume fraction into density of water plus volume fraction of the air into density of the air. Same thing can be done for viscosity. But still, when you are looking at this particular formulation, this doesn't have the effect of the turbulence. So to include the effect of the turbulence, you need one more additional term, that is rho into nu T, that is turbulent kinetic viscosity. So all these three models, if you see, till now what I said, that is going to be retained same. The only difference that is going to have in these three models is how you are handling this turbulent kinetic viscosity. For this, you generally employ, if you are going to employ K epsilon model, where you have kinetic energy equation 1 and dissipation equation. Inside these K and epsilon equations, you will have a term of density. So in this density, if you are treating as a multi-phase, then it will come as multi-phase K epsilon model. But conventional model, which is available in the open form, doesn't have that option. They treat as a single phase. So though the entire system is treated as multi-phase, just the only rho term inside VT is treated as a single phase. That is the constraint which is available in the default model available in the open form. Now, when you are solving in multi-phase, all the 5 equations, momentum equations, continuity equations, volume fraction, and K and epsilon equations, all this will be done in an explicit way. And when you go for the next model, that is Boyan's model, that is K omega model, where there is an additional provision given for one more term called as buoyancy. Because when the wave and the air interacts, there is some buoyancy that is going to come into play. So they have given one more additional term for the buoyancy. This is a basic difference between these three models, which I have been testing for this particular one. Now, what am I trying to test here is, because entire 3D, before going for 3D model, we thought of doing in a first 2D model, where we are taking a transit at the center line of the reef. So here you can see the reef, green color is the wedge-shaped reef, which is sitting on the reef base, which is sitting on the seabed. We have an inlet condition from which we will be generating the waves. For generating the waves, we are using Olaflow toolbox, which is available with the open form, and we have the outlet also conditions. So before modeling directly this reef, first we thought of testing the model. For this, what we have done is we have taken a numerical wave tank, which dimensions are almost similar to what we are testing the reef in. So for that, we have taken length of around 550 meters long wave tank with 15 meters height, in which water depth is 8 meters. And you have the top condition as atmosphere and bottom as a flat bottom. Now here we have taken wave parameters as h as 1.5 meters and time period as 10 seconds. If you see by h by gt square, d by gt square plot, which theory has to be used for this particular depth things, then it is Stokes second order. So we have employed the Stokes second order for generating the wave at the inlet for this boundary conditions. Then when we had a look, these three shows how the K epsilon, multi-phase K epsilon and Buoyant models, the output looks like. You can see a white line here, which is actually the interface between water and air. But if you see in the K epsilon model, you are able to see a lot of red color here. That is because of the excessive production of the turbulent kinematic viscosity, which is happening in the K epsilon model. When it is coming to multi-phase K epsilon model, that much of excessive production of kinematic viscosity is not there, but still you can see some strains of production at some of the locations. When you go for add the buoyancy term in K omega model, even that we are not able to see. But however, K epsilon, K omega models almost behave in the same way, but not much major difference. Only slight difference is then when you use the buoyancy term in the K omega model. So because of this excessive production of the turbulent kinematic viscosity, what is happening is, when we take the wave gauges at 30 meters, 200 meters, 350 meters, and 450 meters, when you propagate the wave at the inlet, by the time it reaches your structure, because of this excessive turbulent kinematic viscosity that is being coming, so what is happening is your wave is actually dampening. That is what you can see here. The dampening of the wave is happening. And if you see the K epsilon model, multi-phase K epsilon model, you don't see much of the dampening happening, and same thing with the K omega model. So from here, we can say that if you are using default K epsilon model, though you generate a wave of some magnitude at the top, by the time it comes to the actual structure or something, it is going to dissipate. So you cannot go with the default K epsilon model here. And this is caused because of this excessive production, which I was saying. Then we have brought the actual reef into the picture now in the wave flume. So this is the reef, and the green color part is the reef, which is sitting on the bed. And we have simulated the same H1.5 and same conditions we have simulated. Now bottom, if you see the again same kind turbulent kinematic viscosity, you can see red strains of the thing which is happening here at the interface, and when the wave is breaking, this is actually getting more intensified. That excessive production is getting more intensified, and this is how the simulation looks like. You can see here clearly that wave propagation is almost looking same, but after some time you can see in the K epsilon model that here particularly if you see there is lot of excessive generation of the viscosity, that you can see a lot of red thing coming up here, and there will be some red strains which are observed in the while propagating the wave also. Here you can see it clearly. Now next, after seeing the viscosity terms and all, then next important thing is we need to see the how wave breaking is actually really captured in these three models. For this, if you see the default K epsilon model, you can see that the wave is not feeling the bottom. It is actually moving till the coast, and that is actually breaking on the coast. But if you see the multi-phase and buoyant K epsilon model, actually at this particular depth, it is supposed to go for a depth-induced bracing, which is depth-induced breaking, which is able to be captured at this particular stretch. You can see that breaking is happening when it is entering into the shallow depth. That is there both in the K epsilon model, multi-phase model, as well as the buoyant model, which is not being captured in the default model. So this is one of the limitations, that we are not able to capture the depth-induced breaking in your K epsilon model. This is how the transformation has been happening. You can see that in the K epsilon model, the wave, whatever I was saying, if you see the timestamps, just to make it much more clear, I have kept a timestamp. You see the wave propagating. Even in the shallow waters, it will propagate without the breaking. When you see K epsilon model multi-phase, you can see that the wave keeps on breaking, and same thing is captured in the buoyant K epsilon model also. So once we are done with it, in the next stage, what we are planning to do is we are going to simulate same thing in a 3D model. We are going to go for the second.
Your time is up. Please wind up.
Last slide, sir. I'm going to conclude it, sir. So we are going to test these two in the 3D model, and we have done also field measurements. Those measurements will be used for validation of this one. That is what is the future work which we are going to do. So final conclusion is we have tested 3 models for this kind of large structure. Then we have understood that default K epsilon model generates excessive turbulent kinematic viscosity, and there is also damping that is happening in the K epsilon model. And even K epsilon default model is not able to capture the wave breaking, whereas the other 2 models are able to capture the wave breaking. These are the reference which we have used, and thank you.
Thank you, Satyakiran Raju Alluri. It is really an interesting presentation. Now we can take 1 or 2 questions. You can post in the chat box if anybody has any questions, and we can request Raju to answer. Till now, no questions have come. Any questions from anybody? You can just key in the chat box. Okay, I think there are no questions, so we will all thank Raju for giving an excellent presentation. Thank you very much, Raju.
Thank you, sir.
So we will now move on. We'll come back to Mr. Gautaman if he is now ready with his presentation. Gautaman, are you ready?
Can you hear me, sir?
Yes, loud and clear. Yes.
Yeah, okay.
So Gautaman, you can start your presentation.
Okay, sir. Can you hear me, sir? Can you hear me, and can you see the screen?
We can see you. No, we can hear you, but we can't see anything. I mean, it's only your screen of the folders only are visible. The file can't be previewed.
Can you take some time?
I think the screen is not correct. And Arnab, you have his
presentation. Yeah. Shall I open it? I think I can
please.
open it.
Yeah, please open it.
Gautaman, please off your screen. Please off your screen. I will open from here.
Okay.
You just off it. Screen off. Screen sharing is off.
I have to say hide. Okay.
Yeah. You have to say hide. One minute.
I suggest if it is
1
taking
minute.
time.
1 minute. No,
you-
1 minute. 1 minute. It's coming.
Okay.
It's coming now.
Yes, now it is visible. Yes.
Yeah, I
Gautaman,
think
you
it's
can
visible.
go ahead. Yes.
Hello?
Gautaman, please go ahead.
Gautam, please go ahead with your sound.
You are muted.
Please don't mute it, Gautam. Gautam, just go ahead. Don't mute it. Gautam?
I don't know. I think you have to check.
Am I audible now?
Yeah,
Yes,
you're audible
you are
now.
audible.
You just go
Okay.
ahead.
Please go ahead.
Okay.
Listen, yeah.
Good morning, everyone. This is just a performance of C profiler during the sea trials that what we conducted of Chennai. And we have developed a ocean observation system, namely a sea profiler, to collect ocean parameters such as conductivity, temperature, and depth. These parameters are important in determining our OML, that is our ocean mixed layer depth and properties. Sea Profiler is an underway automated system to take continuous near vertical data profiles in our ocean mixed layer. We developed a control system for Sea Profiler, which operates and control and also to monitor the performance, with the main objective of to collect the mixed layer data while vessel in motion. There are already many different ocean observation systems which are in the motion, and comparatively, this has got more advantages. Like data collection is done while on the move. We don't have to stop the ship. Real-time onboard data retrieval and monitoring is possible. Need of lifting the probe to deck for data retrieval is avoided. This is the same case in the UCTD, that we have to retrieve the probe on deck to retrieve the data. Real-time decisions on site-specific profiling depth and the track can be made without lifting the profiler to deck. The swift change of different sensors heads on deck enables observation of various ocean parameters without extra profiler, because we can add sound velocity as well as turbidity also along with that. System control can be made remotely, and we can operate from anywhere from the deck. It can generate the distance between two consecutive profiles also. The system gives angle of verticality with normal in real time to control the speed of vessel. Next slide, please. So the main parts of the C profiler are CTD sensor, which is inside this toe fish, and the toe fish and the electromechanical cable, the winch, the control system, and also the data acquisition systems. So basically, it is fixed on the ship aft side, and then the profiling probe is lowered from the A-frame from that side, and they have the data logger, control box, the winch, A-frame, toe fish, or all except the toe fish, all are run on board. And when the ship is in the particular moving direction, you get a profiling path as well as a retrieval path in both mixed in the same profiler. Next slide, please. The As you can see here, the winch was fixed in the in the aft side of the Manjusha, and it took just 4 hours for fixing the winch over there on the base, and that base can be again used when we come out of the ship, and then we can use in the different ships also. So it is planned in such a way that we can get away from the ship without disturbing the other operations, so with the minimum possible installation time. And you can see on the right side that the towfish was lowered, and then the probe was then towed in two different trials. Both of them happened off Chennai only, and in two different situations. You can see on the bottom left side corner that the probe is there seen on the back of the towfish. It's held in this fashion, and then when we lower it and then start towing in a particular speed, you get two parameters, and you can see in that laptop screen there are two parameters shown there, and both of them are then compared with the existing CTD sensor which was there on board. And next slide, please. And then both the parameters were seen with a graph, as you see, then the depth on the left side and the conductivity and temperature uh, for 100-meter depth. Can you see? Next slide, please. And this is
Yeah.
again comparison with that with the ship CTD. And next slide, please. A correlation coefficient was derived from that. And next slide, please. No, yeah. So it is the coefficient was 0.9954 in 0.99 for both conductivity and temperature. Next slide, please. Here is the total profile that we have made for the tow during the second trial cruise. This was also on the off Chennai area. The time versus depth here you can see as ascent and descent. Next slide, please. Yeah. So this is the experience that we had, and we are into improving the observation quality as well as increasing the depth. These are all the future plans that we have, and also we would want to have user-friendly cruise in which whatever the input that we are going to have from the users that it can be incorporated in that. This is the present situation, and we are looking forward for improving it and to have more parameters attached to that. Thank you. Any queries, please?
Thank you, Mr. Gautaman, for the excellent presentation of the work which has been done. Now the floor is open for questions. Also, there is some more time left. So, if anybody has got some questions, you can put in the
Gautaman,
chat, please.
I have one question.
Yes, please.
You can put in the. Okay, you ask.
Yeah, I'm just asking actually. What are the after collecting the data from the SIP? What are the correction you are doing to making like SIP-based correction? What the correction you actually applied on data? Have you applied on it?
No. Actually, there is a GPS already fixed with the winch itself. So
Okay.
there is no need of any corrections as such, and we can directly use it.
You are not in no need of any kind of correction.
No.
Like in movement.
No, nothing. We don't need any corrections for this.
Okay. Okay, fine.
Any other question anybody has got? Please feel free. Those who are viewing it from outside, you can just put it in the chat box, please.
I have also put it on this YouTube channel where on the chat thing, if there is anybody have any question, can.
Yes. We'll wait for a minute so that anyway, some time is there left. So we will wait for a minute for any further questions before we move to the next presenter.
In the meanwhile, maybe we can ask the presenter to share his slides and we can still wait for the questions.
Yes, of course. Looks like there are no questions. Pramod,
Okay, sir.
anything
Thank
has
you.
come? Anything has come in the video chat?
No, sir. On YouTube also there is no questions yet.
Okay, then fine. Thank you very much, Gautaman. I mean, it's a good presentation. Thank you very much. Now we will.
Thank you, sir. Thank you very much.
Thank you. We will now move on to the next presentation by D. Nandini, that is on seasonal sediment characteristics analysis of Kandla Creek and Gulf of Kutch. Over to you, Nandini. Please go ahead. You can start your presentation. Nandini, can you hear?
Yeah, hello. So can you
yes,
hear me?
please go ahead. Your voice is clear and presentation is fine. Please go ahead. You can switch on your video if you have one. Nandini, can you hear?
Hello.
Yes, you please go ahead. You can switch on your video also if it is possible and then start the presentation. Can you hear, Nandini? Is there some problem?
Hello. So can you hear me?
Yes, we can hear you. Please go ahead.
Yeah, you are audible.
Looks like she's not able to hear us.
Actually, may I ask Dr. Sundar Swami to stop sharing the screen? Unless you stop it, then other cannot get in.
Hello. So
Can you?
Hello?
Yes, we can
Yeah,
hear
yeah.
you.
Yeah, we can hear.
Hello.
We can hear you, Nandini. Please go ahead. I am putting in the chat also to please go ahead. Looks like she is not able to hear us.
Yeah, we can hear you.
No, she is not able to hear us, so she is not able to get any feedback.
Now I can.
Now it's fine. Please
Yeah,
go
yeah,
ahead.
that's fine. Yeah,
If
go
you
ahead.
can switch on your video, that will be good. Otherwise, you can start your presentation.
Yeah.
Please go ahead, Nandini.
Yes. Yeah. Good morning. This is Nandini from Department of Ocean Engineering, IIT Madras. Today I'm going to discuss about the topic of seasonal sediment characteristics analysis of Kandla Creek and Gulf of Kutch. So before going to explain about the soil texture and other things, I'll just briefly discuss about my study region. So the greatest tidal ranges are found in the Arabian Sea are notably at the Gulf of Cambat.
Nandini, looks like you are switched on two systems. One of them you muted. Now you go ahead. Now it will be fine.
Yeah. Yes, sir. So the greatest tidal ranges are found in the Arabian Sea, notably at the Gulf of Cambat and Gulf of Kutch. So the Gulf of Kutch region is located in the northwest India. So this is highly irregular configurations with the number of islands, mudflats, and creeks, bays, marshes, and reefs. About 10 small and large ports, along with many other natural and anthropologic morphological features. So the tidal height in the Kandla Creek ranges from 0.83 to 7.2 meter, with an average of 4 meters. So the morphodynamics and hydrodynamic process are mainly influenced by the dynamics of sediments. The tide-induced currents is a key factor to initiate the sediment motion. So in such macro-tidal regions like Kandla, the influence of the tides on sedimentation process and significance in the form of a dispersal pattern. So the sediment dispersal pattern results from the association of high tide range and with the variation in the geometry of the basins. So its geographical location, climate change, and the quantity of the sediments, all the things are contributed to it due to the source and sinks within the flow regimes. So the mainly Kanla Creek is Creek's hydrodynamic and morphodynamics are influenced by two factors. One is river discharge in the upstreams and the macro tides in the downstreams. So the river and tide combine the natural forces on inevitable physical modifications in the sediment movement and sediment distribution pattern inside the creek and Gulf of Kutch. So the understanding the seabed sediment characteristics is one of the most fundamental parameter of any sustainable coastal development, and also the seasonal seabed sediment variation study is another important requirement for enhancement of the knowledge about the seabed sediment characteristics, which can be achieved only through extensive in situ measurement and lab analysis learning. So this is the method and methodology involved in the process. So the main objective of this study is the seabed sediment characteristic change identification on spatial as well as temporal over the different periods named pre-monsoon, monsoon, and post-monsoon period, with the change in intensity influences of river and tidal currents along the Kanla Creek and entire Gulf of Kutch through the field sampling and laboratory analysis. So this region was exposed by diurnal tides with the macro tide ranges of 7.2 meters. So these are characterized by the sediment dominated of fluvial marine origin. So totally in the region, we have collected 8 seabed sediment samples. Using the sampling depth ranges between around 5 to 18 meters, and it was achieved by the experienced engineer using the van beam grab sampler equipment fixed at one side of the survey boat, along with the another vessel mounted with the dual frequency single beam echo sounder. So, and the DGPS, digital differential global positioning, DGPS, during all the 3 sets of sampling and the seasons are also used. Then the geographical sampling locations were captured using the help of DGPS, and the respective depths were marked using the echo sounder. Then the field samples were transferred to the polythene Ziploc bags, which were labeled and stored for the laboratory analysis. Then the automatic sieve shaker equipment, ASSC, used for the particle size analysis. So after drying the each samples in the hot air oven at the temperature of 105 degrees Celsius for 24 hours, then the samples were allowed for the natural atmospheric cooling process before taking for the weighing process. So the in situ bed sediments for the 3 samples in the Kanla Creek were allowed in the ASC equipment aimed in the identification of particle size distribution in order to identify the sediment texture and pattern. Then the sieve size analysis is carried out by passing the total 500 grams of bed sediment successively through the decreasing sieve sizes. So then this ASCC allowed the sufficient continuous mechanical motion with the reliable accuracy and repeatability of 15 minutes for the particles separation by combined back and forthrightal motion with up and down tilting motion. So this process allowed the particles to travel in the orbital directions on the sieve surface. So the amount of sediment collected in each sieve were weighed, and the percentage weight in the fraction were determined. So finally, using the pycnometer, the specific gravity for all the 8 samples were analysis for all the 3 seasons. Then this is my study region. So in this image, we can see that samples S1 to S3 are located in the Kanla Creek zone, and the sample S4 and S5 located in the intersection zone between the Kanla Creek and Gulf of Kutch, that means the mouth of the creek. Then samples S6 to S8, which are located in the Gulf of Kutch region. So the particle size analysis studies and distributions for all the eight different locations with the different depths for all the 3 seasons. So the samples collected for the pre-monsoon or in the month between March to June 2019 And July to October 2019 falls in the monsoon season. The sampling of post-monsoon season has been done in the period of November 2019 to February 2020. So the bed sediment characteristics for all the three zones were done separately, and all the three seasons were compared. And from the results of the grain size distribution, we can see that the samples S1, S2, S3, which are located in the Kandla Creek region, those are maximum, shows that the samples with more than 90% of the sand, which confirms that a major river discharge influence during the pre-monsoon season. Actually, at the top of these top of the creek, the tributary rivers or the contributors for the sediment motion in the monsoon and post-monsoon seasons. So, which are the major influence for the sediment texture which captured in the creek region? So, samples S1 and S2, S3 locations for all the three seasons contains more than 90% of the sand, which confirms that major river discharge influence. During pre-monsoon, the S4 location samples fall in the sandy clay loam category, whereas during a monsoon and post-monsoon season, which shows more than 90% of the sand, that confirms that the river flow during these two seasons dominating the transportation than the tidal flow currents. So during the pre-monsoon, S5 samples shows around 60% of silty clay, but during monsoon it seems dominated by 60% of clay silt and 50% of clay silt during post-monsoon. So which shows that the typical seasonal variations and the combined effect of river and tidal influences are the dominating factors. Then coming to the sample S6, it shows that the silt loam during the pre-monsoon season and other monsoon and post-monsoon season, it maximum shows the sand and sandy loam. So S7 shows the silt clay during the pre-monsoon and silty loam during the monsoon and post-monsoon. Coming to sample S8, located in the Gulf of Kutch at the endmost point, that shows that sandy loam during the pre-monsoon and silty loam during the monsoon and post-monsoon. So based on the combined analysis of all the three seasons, we can tell that sample S6 to S8 project the typical tide current domination in the Gulf of Kutch region. So the specific gravity was varying between 2.6 to 2.74 in the creek, and mouth it shows maximum 2.68, but in the Gulf of Kutch it shows about maximum 2.74. So this confirms that the salinity decreases into the creek during the monsoon and also during the downwelling period. So based on this analysis, we can conclude a few of the things, and based on particle size analysis for the three season confirm that the sand dominates in the creek region. So it shows that there is not much variation inside the creek hydrodynamics because of the tide, wave and current influences. So coming to the second zone, mouth section, so that plays an intersection zone between the creek and gulf. So that indicates maximum silty clay presence during the pre-monsoon, whereas sand and clay dominates during other two monsoon and post-monsoon seasons. So these variation demonstrate that the influence of river water discharge added during the monsoon period and the tidal influence during the non-monsoon periods. So coming to the zone 3, Gulf of Kutch region, it shows the silty loam during all the three seasons, pre-monsoon, monsoon and post-monsoon. So this may be due to the hypertidal circulation inside the Gulf of Kutch. So further, in order to extend the study, we can go further other analysis like total suspended sediment analysis and other discharge measurement and other things. And also we are in a developing stage of 3D hydrodynamic modeling of the same domain in order to get the better understanding of the tidal and other processes in the Gulf of Kutch region. Thank you, sir. Any other questions?
Thank you, Nandini, for exactly stopping at the stipulated time. The floor is now open for some questions. If anybody has got questions, please put it in the chat box. Maybe I will
Hello?
ask you. Yes, please go
Yeah,
ahead.
I am asking one question. Nandini, can you tell me what are the tidal current range you have found? Any idea in the Gulf of Kutch?
Yes, sir. In the open ocean, we can maximum get the around 11 meter. It's possible, but inside the creek, around 7.3 meter is a maximum tide occurs. So the average tide range is around 4 meter inside the creek.
No, that is tidal height. You have any idea about tidal current? Like in centimeter per second, that unit. That is the tidal height you found maximum 11 meter, right?
Yeah, yes, sir.
So
That is
current
in the open ocean. That is in the open ocean. I mean, Gulf of Kutch. So inside the creek, it's the average tide is around 4 to 5 meter.
But you have not checked about the tidal current. That is the total current will be there. Na? In that, there is a tidal component also will be there. So you have not checked on that. How much
Yes,
the
sir.
range?
Yes, sir. Based on numerical models,
Yeah.
we can come that around during the flooding and ebbing period, it's around 0.2 to 0.35 meters the maximum tidal current occurred in the study area, sir.
Based on model study, right?
Yes, sir. Based on 2D model setup.
Okay, fine.
You mean to say that only 0.3 meter per second, is it?
Yeah,
That's
yeah.
what.
Yes, sir. Yes.
That looks to be quite low for that region.
Quite low.
I think it is.
Sir, I'm talking about inside the creek region, sir.
Inside the creek. Okay.
Inside the creek,
Yeah.
because the Deen Dayal port is located inside the
Okay.
creek.
Not in the Gulf. Not in the Gulf.
Yes, sir. Yeah, not in the Gulf. I'm talking about inside the creek. DPT port is located inside the creek. So
maybe
we are yes,
fine.
sir.
That is fine. If Ramanamurthy is online, he can able to talk more on this. I think.
One minute. I think Miss Nandini, it is good that I think you have done a good model and all. But only this 0.2, 0.3, if you go with that, you will really get into trouble. It will be more than 1 meters per second. Please check that. See,
yes,
what
yes,
happened? You are
around
working with
0.9 to 1 meter in the Gulf of Kutch region, sir. So I'm talking about inside the creek.
the creek. It will be more, ma. It will be more. It will not be less. So you please check that. Anyhow, because you are going to give us somewhere else. No, please check that. It will be more.
Yeah, sure, sir.
Yeah. Okay.
Okay, good. Nandini, you gave a good presentation. Good work. You are a dual degree student, is it, of IIT Madras, Ocean Engineering?
I'm research scholar, sir.
You are a research scholar. Very good.
Yeah.
Okay, thank you. Thank you very much, Nandini. We will move on to the next presentation. Next presentation is by Reshma George. She will speak about physical model studies on damage and stability analysis of breakwaters with double layer GSE armor units. Reshma, you are online? Yes.
Yes,
if you are able to show your video on, that would be good if it is possible. Otherwise, you can go ahead with the presentation.
Yes, sir. Good morning, everyone. My name is Reshma George from Department of Water Resources and Ocean Engineering at NITK. The title of my topic is Physical Model Studies on the Damage and Stability Analysis of breakwaters with double layer GSE armor units. So breakwaters are structures that are built with the purpose of attracting strong waves on them and thereby protecting the harbor area or the shoreline. So usually for rubble mount breakwaters, we use heavy stones or artificial concrete armor units with the purpose of wave energy dissipation. But these are very costly, they have less availability and have strong environmental impacts. So the need of replacement of these armor units by a more suitable alternative has led to the application of geotextile sandbags as primary armor units. And this has several advantages because when geotextile bags, when they're filled with sand, it acts just similar to the stone armors and it could be an efficient alternative at places where stone mining is not possible. And also large units would reduce the construction cost and these GSE armors could be placed to steeper slopes than the conventional armors. And also wide range of uniformly sized units could be made. And even if they get vandalized and sand is expelled from GSE units, they don't pose an environmental threat. And if damaged, these structures could be easily modified and reshaped. And they're environmentally friendly structures that promote biological growth on them. So coming on to the literature review, geotextiles were first used for road constructions at the South Carolina Highway Department in 1920s. But GSEs as a defense mechanism for coastal protection was first used in 1950s in Netherlands for the construction of an inlet pipe. Since then, there has been numerous improvements in its coastal protection technologies with regard to durability, UV resistance, hydraulic stability, and failure modes. So in 2015, Schiller et al. Conducted a physical model study of a submerged reef where the GSE armor units were aligned in 3 different patterns, that is the perpendicular arrangement, parallel, and Flemish arrangement. Only the parallel arrangement was considered in as a single and double layer arrangement. And this study concluded that the alignment of GSE armor units as a parallel double layer was the most stable configuration for the reef structure. So coming on to the stability studies for GSE bags, earlier GSE structures were designed using the Hudson's formula, which is the hydraulic stability formula for stone armors. And the limitations of using this formula is that it considers an empirical coefficient KD that is specific for stone armors, and also it doesn't take into account the effect of time period of waves. So later, Wouters formula was introduced, which is a stability formula explicitly for GSE structures based on Hudson's formula and also the previous experimental data. So this formula introduced a new empirical coefficient, that is CW, which is more specific for GSE armor units. And also it introduced another parameter, epsilon 0, to take into account the effect of time period of waves. Later, Omrasi et al. Introduced 2 formulas for the slope and crest GSEs. And he also introduced an empirical parameter value, that is CW equal to 2.75. So coming on to the damage classification, a new method was introduced for damage classification by Dasnaige and Omrasi in 2012, as the conventional classification method for coastal structures is not possible for GSE structures. So as per this, first of all, we identify whichever the critical layers are, which these critical layers are those layers which are experiencing most amount of wave interaction and resulting deformation. So a percentage damage was calculated based on the number of units displaced or detached from these critical layers. And each test case was classified from a damage classification range ranging from DC0 to DC4, where DC0 stands for damage classification 0 or no-damage classification, which is the most stable condition where less than 10% of the critical GSEs have moved and no critical GSEs have been detached. And DC4 corresponds to the total failure condition where more than 40% of critical GSEs have moved. And the objectives of the present investigation is to carry out a stability and damage analysis on the breakwater model for studying its feasibility of using as an actual prototype in the field with GSE bags as primary armor layer, and also to study the effect of the different patterns of alignment of GSE bags on the stability of the structure. And this is coming on to the experimental study. The physical model study was carried out at 2-dimensional wave flume at NITK Marine Structures Laboratory. And a built-in beach of slope 1:12 is provided at the other end of the wave generator, which consists of a bottom hinge flap. So as seen in the figure, a double layer of GSE armor units was used, and the experimental model consisted of 3 different arrangements and also tested for 3 different water depths, that is 50 centimeter, 45 and 40 centimeter. The first arrangement is the parallel to wave arrangement, where the bags were aligned parallel to the direction of propagation of the waves, and these bags had a longitudinal overlapping by 50%. And the next one is Flemish arrangement, where bags were placed alternatively in parallel and perpendicular fashion. And here also there was an overlapping by 50%. And lastly, parallel to slope arrangement, where GSE bags were aligned parallel to the slope of the structure and they were not overlapping. So basically the test cases consisted of 3 different alignments and tested for 3 water depths and tested with waves of time periods ranging from 1.4 seconds to 2.2 seconds and wave heights ranging from 6 centimeter to 14 centimeter. So this is the response of the breakwater structure at the water depth of 50 centimeter under waves of time period 1.4 seconds and wave height of 6 centimeter. So as it's the parallel to wave alignment, it's mostly stable. And coming on to the results and discussion, studying stability of breakwater armor with double-layer GRC armor units, the variation of stability number with respect to surf similarity parameter was studied. And for each test case, an incipient motion curve was drawn. For this, the CW value was calculated as per this equation given by CW equal to NS in the root of epsilon 0. And the average value for all the incipient motion test cases were found out, and a curve was drawn. So the importance of this curve is that whichever test cases that are lying below this test case falls in the stability region, and whichever cases that are crossing above the line represents the unstable condition. So here for the parallel to wave arrangement, this curve is plotted for different water depths. And as shown in the figure, we can see that as water depth is increasing from 40 centimeter to 50 centimeter, the fraction of test cases that is lying below the curve is decreasing. And similarly, this incipient motion curves were drawn for the Flemish arrangement and also the parallel to slope arrangement. And now for comparing the effect of different alignments of GSE bags on the stability of the structure, for each water depth, the influence of stability number as the arrangement is changed is studied. So here for 40 centimeter depth, stability number is found to be higher for the parallel to wave arrangement, and it is followed by the Flemish arrangement and then the parallel to slope arrangement. So similar pattern is visible for other water depths, that's 45 centimeter and 50 centimeter. For 50 centimeter, almost stability curves for three alignments is almost coinciding. So the effect of incident wave heights on the damage levels was studied. For this, the curve was plotted between incident wave heights and damage levels. So on the y-axis, the damage levels are ranging from DC0 to DC4. So whichever portion is colored represents the stable region that ranges from DC0 to DC1. And we can see that for most of the test cases, that is from time period ranging from 2.2 to 1.4 seconds, we can see that the portion of stable cases is more for the parallel to wave alignment. And for every alignment, the damage level keeps on increasing with increase in the incident wave height. And this damage level is highest for parallel to slope arrangement for all cases. So similar plots were created 45 centimeter water depth and also 50 centimeter water depth. So at 40 centimeter water depth, what is the effect of change in time period of waves from extreme case of 1.4 seconds to 2.2 seconds was studied. So this showed that at a minimum wave period of 1.4 seconds, the structure could withstand a wave heights up to 0.109 meter. But when it was changed to 2.2 second waves, the structure could withstand waves up to 0.123 meter. So this showed that when the time period was varied from 1.4 seconds to 2.2 seconds, the structure could withstand 52.38% higher waves. So this was because these large time period waves were of low frequency and they were gentle and possessed less energy and hence caused less damage to the structure. So coming on to the conclusions, the stability of the breakwater armor with double-layer GSE units were found to be highest for the parallel to wave alignment, and it was followed by the Flemish arrangement, and the least stable one was the parallel to stable configuration. And the structure was found to be able to withstand a maximum wave height of 10.9 centimeter, which accounts to 3.27 meter in the prototype. And the damage levels were found to increase for high frequency waves. And for the breakwater structure with parallel to wave alignment, it could withstand 52.38% higher waves when the time period was increased from 1.4 seconds to 2.2 seconds for the 40 centimeter water depth test case. These are my references. Thank you.
Thank you very much for your excellent lucid presentation of the work. Now the floor is open for questions. Anybody has got any questions, you can put in the chat box. Meanwhile, I will just ask her a question, Reshma, that is, you have done this experimental work at NIT Surathkal, am I right?
Yes, yes, sir.
Okay, so did you validate it with actual some experiment in the sea or something? Because you have got a, NIT Surathkal is quite close to the sea, is it not?
Yes, sir. Yes, sir. Sir, but I have just conducted this physical model study at lab only.
I see. Okay, you are a PhD scholar, is it?
No, sir. I'm tech student.
Oh, I'm tech student. Okay.
Yes.
Okay then. Thank you. Let us wait for any more questions.
Yes, sir.
I have one question, Chairman. If it is.
Yes, please, Ramanamurthy. Please go ahead.
I think, Rashma, I think you have done good work. Maybe doing at this level, MTech is really excellent work. But have you compared anything with any of the empirical formulae which was already existing on that particular day?
No, sir. Like, so you're talking about empirical formula for stability. Yes, I have used the Omrosi's formula as I have shown in the presentation.
Okay.
But it included just physical model study. I haven't done any numerical or analytical study.
Okay. Okay.
Yes, sir. Yes.
Any more questions from anybody? You can put in the chat box, please. Okay, looks like there are no questions. Anything, Pramod, from the YouTube side?
Not even the YouTube side, there is no question.
Okay, then thank you very much, Reshma. That was an excellent presentation. Let us now move on to the next presentation. That is by Tappala Vikrant on real-time estuary observatory system for monitoring Havanapadu estuary by utilizing Internet of Underwater Things. So, Mr. Tappala Vikrant, you are there?
Yes, sir. Yes, sir. Am I audible, sir?
Yes, yes, you are audible, and you can start your presentation.
Okay, sir. I'm Vikrant. I'm presenting here my MTech dissertation work, which is done in the Department of Meteorology and Oceanography, Andhra University, in collaboration with NIOT as an intern student. I have developed a real-time estuary observatory system to monitor the estuary properties, physical properties, and the main objective of this study is to design an observatory system to investigate the influence of tidal current on the estuary. The designed real-time estuary observatory system is deployed in the estuary location and collected real-time data. This observatory system consists of 4 different platforms, such as Mood by Observatory, which is to collect the air temperature, humidity, water temperature at a different depths, underwater pressure, and a tilt chronometer used to collect the measure the subsurface tidal currents, and the surface drifter used to collect the surface tidal current velocity and direction, and a remotely operated surface vehicle to collect the surface temperature and salinity, and final platform is onboard field measurements. This real-time estuary observatory system comes under the coastal observatory system, which is involved in consists of 4 observatory platforms. The data collected by all these 4 observatory platforms going to share through the Internet of Things cloud. Once data uploaded to the cloud, it's easy to download from the cloud, and this data will be purified. Once the data purified, it can further given to the input for physical models to see the forecast or the next step of the current location. This observatory system consists of 2 data acquisition systems. One is surface data acquisition system and subsurface data acquisition system. In surface data acquisition system, the Mood by Observatory, surface drifter, and remotely operated surface vehicle comes, and subsurface data acquisition system, which collects the subsurface parameters, which is installed in the Mood by Observatory and onboard field measurements. And this is my application. Estuary is a partially enclosed water body where the fresh and salt water tends to mix, and it is an unique ecosystem that tends to be unstable because of dynamic mixing of fresh and salt water. And this is the area of study, which is located at the northeast coast of India. And this is the Banpadu Creek, and this is my area of study. And the observatory 1 was deployed at the 2 locations. 2 observatories was deployed. One is near to the creek mouth, which is 400 meters from the sea, and another one is 1.2 kilometers from the seaside. And this is the surface view 3D model of the moved by observatory, which consists of beacon lights, solar panels, and electrical components, and IoT communication system and everything. This is the subsurface view of the moved by observatory, where the temperature sensors was installed at 0.5 meter depth, 1 meter, 2 meter, and 2.8 meter depth. And this is the overall view of the moved by observatory. And this is how the data sharing going to take place. Once the data collected by the moved by observatory stores locally into the microcontroller, and it gets the internet signals from the nearest cell phone tower. Once it gets the signals from the nearest cell phone, it's going to share the data to the cloud in the from the remote location. Once the data uploaded to the cloud, it can be easily accessed from the base station and can be downloaded. And the data flowchart is going to show in this way. Since it consists of solar panel, it will be controlled by the solar charge controller and further connected with a battery unit. This battery unit connected with a small microcontroller, which is further controlled with the relay switch. This relay switch plays an important role for the data collection. The main microcontroller allows the relay switch to send the power for the main controller unit to collect the data. This relay switch allows the microcontroller to collect the data at 10 minutes of time in an hour. First 10 minutes, the microcontroller wakes up and collects the surface data and subsurface data up to every 2 seconds interval of time. Once the 10 minutes completes, and for the next 10 minutes, the entire system goes into sleep. And after next 10 minutes, it's going to wake up and collect the data. Once it stores the data locally, it saves in the SD card, and parallelly, it sends to the Internet of Things with the help of Node MCU Wi-Fi module, which is installed in this observatory. Once the data going to upload to the cloud, it is easily downloadable. And this is how the Google Firebase cloud I have adapted. And the data, each sensor data was uploaded in here. These are the sensors I was used in this platform. And the fabrication of observatory, moved by observatory was done, and it was tested in the lake to see how its stability. And 2 observatory was moved to the Bonpadu Estuary, and it was one Estuary is successfully deployed at the river mouth and as well as the at Estuary. And this is how the monitoring of each and every sensor was done by myself. And if you see the results collected by these 2 observatories, this represents in the Estuary. The blue one represents the air temperature, and the red one, green, and violet represents the water temperatures at variable depths. So here we can see at every high tide happens, there is a rise in temperatures in the estuary. There is fluctuation of water temperatures at 1.5 degrees centigrade. And not only at the high tide, at the low tide also there is a rise in temperatures in the estuary waters. But whereas at the river mouth, there is no separation of water temperature profiles. Everything is uniform, and it shows that near the river mouth, the temperatures are very mixed, is highly mixed. And this plot represents the blue one of underwater pressure with respect to the water temperature. When there is a drop in pressure level, it means when there is a drop in water level in the estuary, there is a rise in temperature. So the same. This was seen in every 8 days of deployment time, which is similar to that river mouth. And the next observatory, in this observatory, have installed a tilt current meter, which is used to measure the subsurface tidal current. This is a tilt-based current meter, which measures the subsurface tidal current with the help of tilt made by the instrument. Here, an initial was installed in this instrument, which consists of gyroscope, accelerometer, and a magnetometer, which measures the initial movement of water. And this is how it was deployed incorporated into the moved by observatory. And if you see the data collected by this tilt current meter, the subsurface tidal current ranges in between 0.2 to maximum at 1.4 meter per second in the estuary. But whereas when you move towards the river mouth side, the tidal velocity is ranging in between 0.5 to 2.1 meter per second at the river mouth side. And this is the direction of the tidal current. The positive value in this plot, the positive values represents at the low tide, and the negative values represents at the high tide, and the direction of the current was flowing with respect to east and west to east direction. And the next observatory was the surface drifter. The surface drifter is used to collect the surface tidal currents, and it is deployed. Actually, it's a semi-Lagrangian way of measuring the surface tidal current, velocity, and direction. It has a moved with a small dead weight with the help of rope, with a length of rope around 50 meters of rope. So it is allowed to see the trajectories, how it is following. So in order to select a good drifter, I have done a computational fluid dynamic analysis at the different designs and a hydrodynamic diffraction analysis to see the behavior at different wave conditions. And the GPS tracker was installed in this drifter to see to track the trajectory of the surface current. And the fabrication was done, and it is went to the field, and field trials was done. It is moved, and it noted that the surface velocity was seen in between at 0.6 meter per second to 0.06 meter per second. And another coastal surface drifter, which is a pure Lagrangian way of measuring the incoming tidal velocity, and same the computational fluid dynamic analysis to perform to select a good design for the surface current, because since it is having lesser depth, it can able to measure the surface currents at 1.5 feet depth. And the surface drifter was also deployed, and during the high tide time, we have deployed the drifter at the creek mouth side, and it is seen that it measures the high tide velocity as 1.6 meter per second, and at the low tide it measures 0.9 meter per second to 0.1 meter per second. And the third observatory is this remotely operated surface vehicle. It is allowed to move from the mouth to the estuary. This is the design, and the same fluid dynamic analysis was done to see how the drag was to check the drag for the propulsion of this vehicle. And similarly, the hydrodynamic diffraction analysis was done to see how it is behaving at the different wave conditions. And this is successfully fabricated and taken to the estuary to collect the data. And results from this surface vehicle that when you move toward the seaside, there is a reduction of surface temperature. Water surface temperature was reducing, but the salinity concentration, surface salinity concentration was start increasing when you move towards the seaside. And the last one was the onboard field measurements. Here the 250 meters equal interval of stations was selected and taken the temperature profiles, salinity profiles. With the temperature profiles, it sees that in the estuary there is a separation of water temperatures, thermocline and so isothermal followed by thermocline and rise in water temperature. But when you're moving toward the seaside, this is moving toward the seaside, there is a well mixed water temperature has seen. But when you come along with the salinity concentration, and in the estuary there is a less surface, less salinity is seen, but at the bottom of the estuary, the salinity concentration was very high. But this trend was reduces when you move toward the seaside. There is a high salinity concentration was noticed, and the real-time data was given to the LSTM deep learning neural network to see the forecast of future forecast. When the network LSTM network was done at this is the air temperature data was given to the LSTM network to get the forecast of 2 days, and the input data is given as 6 days 4 hours of data to predict the next 2 days 3 hours of data. Initially the model ran at 100 hidden layers. The forecast was not up to the mark, and it is further improved and seen that 300 hidden layers and it was up to the mark. And here I conclude that this real-time history observatory system is successfully collected the influence of water properties, how the tidal fluctuations was influencing on it, and the surface currents also measured by this surface drifter, and the real-time data was uploaded to the cloud, and the surface vehicle was deployed in the estuary and collected the real-time water temperature and the salinity concentration. Hence, this observatory was successfully identified how the estuary water properties was influenced by the tidal currents. Thank you, sir.
Thank you. I mean, really, you have done a lot of work. When was this done? Was it done during the COVID period or before that?
Yes, sir. It's done in the COVID situation. Actually, I have moved to the field visit in the month of March. When I started this time, the COVID situation was there.
So I think you have done an excellent job. There is a question from Dr. Ramanamurthy. You can proceed, Ramanamurthy.
Thank you, Chairman. I think, as you said by you, I think he has done a very good work because doing so many observations at one place. But I have only nothing to specifically add. But one small observation, what you have for the system. See, you say there is a temperature variability and all, but rarely did you see your temperature sensors have been calibrated or validated correctly?
Yes, sir. Yes, sir. I have done. But the thing is that I have used a small thermistor probes. The thing is that I have within a week I have found out the biofouling, since it's a rich biological productivity area. I have seen a biofouling. All the temperature probe was covered with it. So what I have done, I have removed the entire string and I have calibrated a new string and I have deployed there. So I have replaced the entire sensors.
That's what exactly is my question, because sometimes what happens is whatever variations which you see, it is because of the biofouling and then drip treat the sensor for that. But I think there is much. But how, with which group you coordinated with NIOT?
Ocean Electronics, sir.
Okay, fine. I think anyway, good work. Thank you, Chairman. I think from my side is all.
Okay, good. There is, looks like one question from Pramod Maurya. Please go ahead, Pramod.
Yeah, hi, Vikrant. It's a very good presentation. And in fact, you have done a lot of things in that, and there's a huge amount of work. So I have one question regarding technical detail of it, which says that you have used Wi-Fi module and you have used Internet of Underwater Things, right?
Yes,
so
sir.
is the Wi-Fi module applicable in that? And what kind of method did you use to transfer the data from base station, from that device to the server? Did you use FTP kind of things, or it was sending messages?
It's FTP, sir.
Okay, and what was the Wi-Fi module doing there?
It's Node MCU. It's an Arduino compatible Node MCU module. From the Wi-Fi what I have given to the observatory, from that Wi-Fi, this Node MCU going to connected to the Google Firebase cloud. So based on the internet strength, so it's going to upload the data continuously.
So you had a network between all of these devices as well.
Yes.
So that network is using Wi-Fi?
Yes, sir.
Okay, yeah, thank you.
I just wanted to check with you a general question only. How many of you worked for this project? Was it you alone, or you had a team to work?
No, sir, it's a teamwork, sir.
How many of you were there?
We are around, actually, main 5 members we are there, sir. But unofficially there are many members, because starting from the transportation side, near the fabrication and fishermen's boat hiring, that will under the secondary.
No, that is fine. I'm asking students.
Myself only involved, sir. It's an MTech project, so I have myself only there, and my guide was Srinivasan, sir, and he helped me. The team, Ocean Electronics team, was helped me. Okay,
anyway, good job. I think you should definitely do some more work and present at the Oceans Conference, which is going to take place at Chennai. I think your work is really good. Okay, any more questions from anybody? Okay, if there are no more questions, thank you very much, Vikrant, for an excellent presentation. We will move on to the next presenter. That is, welcome. That is Mr. Panugmati Vijay Charles. He is going to present about. I'm sorry. It's Akhil Varghese. Akhil Varghese on variability and accuracy in the estimation of sound speed in Indian waters. Akhil Varghese, you can start your presentation. If you have got a video, you can switch it on so that we can see you also. Akhil Varghese, you are there?
Yes, sir. Could you hear me?
Yes. Please go ahead. You can start presenting now. Akhil Varghese.
Okay. Thank you, sir. I'm Akhil Varghese from Department of Physical Oceanography, Pupos. This is a project work as part of my MSc dissertation. A study of variation in estimation of speed of sound in Indian waters. In ocean, sound speed propagate without much attenuation ocean, sounds propagate with a speed of 1,500 meter per second. And sound speed depend on many physical properties of ocean water. Mainly, there are temperature, salinity, and pressure. So that sound speed is higher in warmer water, 4 meter per second per 1 degree Celsius, and higher in saline waters, 1.4 meter per second per 1 PSU. Varies higher in greater pressure, and it varies with 1.7 meter per second per 100 meters. So considering in vertical, sound speed is higher at the surface due to the large variation in temperature and salinity at the surface, and at the deeper depth, sound speed varies only because of the hydrostatic pressure. So the vertical distribution of sound speed determines the path of the sound propagation, and hence the determination of sound speed profile is very much important for acoustic modeling. Typical SSP is shown here. And in a typical SSP, sound speed increases from the surface to an intermediate depth and then decreases. And an SSP composed of mainly the sonic layer depth, SOFA channel, and a critical layer depth. The SLD is that can be visible here. This area may be the first sound speed maxima occur at the surface, and the SOFA region is the region of lower sound speed. Then below that, below the channel depth, sound increases to the same values at the upper layers, and which is called the critical layer depth. So that by for analyzing the SSP, we use gradients of the SSP. So a positive gradient is that the sound speed increases with the depth and sound refract upwards. Negative gradient is considered as sound speed decreases with depth and sound refract downwards. An objective of this to compare the different equations for the estimation of SSP for the Indian waters to understand the effect of salinity in this equation. And we choose two locations in the northern area and to find the best match equation for the Indian Ocean, and also to estimate the error in different equations SSP. The domain which I selected for the study is the North Indian Ocean. Its longitude ranges from 60 to 90 degree east and latitude from 0 to 30 degree north. As this figure shows that the different locations which are selected for the study. S6 location, that SG1 to SG6 is for comparing the variability of different equations by using the climatological data, and a seventh location, SG7, which is used for the comparison, which is used for accurate to identify which equation is best matched for the Indian Ocean, North Indian Ocean, and the climatological data or the equation variability of equations by using climatological data is done on a seasonal scale. There are January, May, July, October are the 4 months which are selected for this study. And climatological data is available from World Ocean Atlas 2009. 1:1 degree resolution data are used, and the in-situ data is from sound velocity recorder, which is a sensor incorporated in MS by AML oceanographic CTD. There are different equations were developed for estimating SSP based on laboratory measurements and experiments. These equations has variability in means of temperature, salinity, pressure, or depth, and the 6 most commonly used equation by researchers are used for this study. That are Frye and Park, Medvin, McKenzie, Chen and Millero, and Del Grosso. Their updated version by Wang and Xu in 1995, based on the temperature scale of 1990, are used. And the last one is Leroy 2008. These equations, temperature range, salinity, and pressure depth ranges are also here. Then from the results and discussion part, first we compare different equations by using climatological data. The SSP of each equation shows that they follow almost a similar trend, but there are some exceptions. In certain stations, the SSPs are compared for the following each stations, which are mutual comparison of SSPs for identifying the variability, and also by comparing coastal to coastal stations, both the coastal stations in Arabian Sea and Bay of Bengal. Likewise for open and northern stations, the coastal stations, this is the SSP of the coastal, open, and the northern stations of both Arabian Sea and Bay of Bengal, and it is only the surface layer region, 0 to 100 meters, and these all are the variability observed in these all SSPs are from the variability observed in January. Then moving to open stations, the maximum sound speed observed equation and the minimum sound speed observed equation, and the difference are tabulated in this here for both open and open Arabian Sea and open Bay of Bengal. From this, due to time constraint, I'm not mentioning about all the details. Most of it is in my paper, and Fry and Buck shows maximum variability in all the season in both Arabian Sea and Bay of Bengal, whereas the minimum variability, whereas the minimum sound speed is exhibited by a Mackenzie SLD and thermocline region, and Leroy for the deeper regions. October at SD1, it shows the maximum sound speed variation on October, whereas SD4 it is on January. And considering the vertical depth, maximum variation is observed in 1000 to 1500 meter. This variation is almost a constant in Arabian Sea and Bay of Bengal. Only a shift in the case of October month in SD4. Then the deep SLD coincide with a higher gradient. The observed deep SLD on January and July as deep SLD, and it is greater than 50 meters, whereas May and October has a shallow SLD and it is less than 15 meters. The deep SLD coincides with a high gradient, positive values, begins from the surface, and a linear SSP noticed at a deep depth of 500 to 1000 meters, and the linear SSP is also visible in SD1 on January, May, October for 1000 to 1500 meters, and an isovelocity layer is noticed. Isovelocity layer is that the gradient where there is not change in sound speed with depth is noticed at a 1200 to 1400 meter depth, and it's clearly visible in Leroy 2008. Moving to coastal stations, the same tabulation is done for here also, and a sharp negative gradient developed after the SLD during October in Arabian Sea, whereas during July and October in Arabian Sea on Arabian Sea on October with a maximum sound speed of 1542.34 meter per second, and the month exhibit maximum variation is January. And open station, a similar track is followed by all the equations in the deeper region. Fry and Buck shows maximum variability during all the seasons in both the stations, and a minimum variability is observed by Mackenzie for SLD and thermocline region, and Leroy for deeper area. We're moving to northern region. In the surface layer region, a different trend of SSPs are found. Here, Fry and Buck shows a higher gradient, and starting from the surface and to the SLD region, and from this, it is clear that these are the 4 months SSP is here. The red line indicates that the Fry here Fry has a greater variation or indicates a different SSP. It's a more clear higher gradient for October month. In both the stations, maximum variability is noticed during October, and it's in case of vertical, it is 1000 to 1500 meters. In Bay of Bengal, no specific patterns was noticed for maximum minimum variation, but for the remaining that Fry and Buck shows maximum sound speed. Some common patterns of SSP Leroy 2008 follow same track while Del Grosso and Medvin follow another parallel track from 100 to 225 meters. Besides Frey and Park, all equations follow same track. Beyond that, they slightly separate, but all equations follow a parallel track. In the case of deeper area, Frey and Park and Chen and Miloro show maximum sound speed from other equation in the Bay of Bengal, but it is not visible in the Arabian Sea. Moving to Institute for identifying the best fit equation in the domain and correlated the above mentioned equation with the actual sound speed data from the SVR, and the data is available for 0 to 500 meters. That's a single this figure shows that the variation from actual data to different equation, or different equation from actual data is shown here in this plot, and again the two others are for the more clarity, for more visual clarity. For more visual clarity, two other ranges separated into two different ranges, that 0 to 100 meter for surface region and 100 to 500 for the thermocline region. From this, it is found that range Frey and Park shows larger deviation from the actual data, whereas for the 0 to SVR data, and it have an error of plus or minus 0.2 meter per second, whereby the previous analysis it's considered that Mackenzie has a standard equation for the North Indian Ocean, and the variation from observing the variation from variation of other equations from Mackenzie, and it shows that the variation is plotted here. From this, it is clear that all equations possess a nonlinear variation, and a highly nonlinear variation for the Medvin and Mackenzie, Frey and Park. Medvin is the black line, and Mackenzie.
So Akhil, you have to wind up. Time is up.
Red. Okay, sir. Thank you. So that the conclusion is, in the case of northern region and at surface, the SSP variability is large in the Arabian Sea, whereas in the thermocline region, it is higher in the Bay of Bengal. So Mackenzie give better agreement with the SVR with an error of plus or minus 0.2 meter per second at a range of 0 to 100 meters. Thank you, sir. Thank you, sir.
Thank you, Mr. Akhil, for giving a good presentation. Now the floor is open for questions, please. Anybody who wants to ask question can put in the chat box. Those who are viewing through YouTube can also put in the questions in YouTube. We'll try to answer. So Akhil, you did this work at NPOL Kochi, is it?
Yes, sir.
So you are a student of, I mean, you did an external project, or how is it? I mean, you are a...
It's a part of my MSc project, MSc dissertation.
Okay, good. Okay, looks like there are no more questions. So thank you, Mr. Akhil, for a very good presentation. We'll move on to the next presentation. That is by Mr. Punugmati Vijay Charles on experimental studies on coastal dike made of geotextile tank containers with coarse aggregate as bedding, core and secondary layers.
Morning, sir.
Good morning. You are online. Yes, audible, and you can put in full screen mode, and if possible, you just switch on your video also. Please go ahead with your presentation.
Good morning, everyone. Today I am P. Vijay Charles from the Department of Water Resources and Ocean Engineering from National Institute of Technology, Karnataka, Surathkal. And today my work is on experimental studies on coastal dike made of GSC bag geotextile sand containers. As we know that world is made of 20% beaches with sand, and then among them 60% are experiencing serious erosional problems due to tides, waves, current, different criteria. And to overcome this problem, we are constructing different kinds of rubble mound like breakwaters, coastal dike, different types. In this, now I choose coastal dike as my experimental work, which are made of geocentric sand containers. Why geosystems are? Because of simplicity in placement, easy of constructability, and the cost effectiveness and minimum impact on environment and different other possible criteria are also there. And as we know, these geotextile systems are of different three types mainly: bags, mattress, and the tubes, which are filled with sand or with a mortar as we choose. And then there is a sand fill ratio which plays a crucial role in these geotextile bags, in which the total available space within the geotextile sand can fill with, and the volume of the filler material, the ratio which we choose. And the type of damage occur on these bags are like the incidental damage, or maybe vandalism, or maybe biological damage. These affect the bags in the real-time conditions. And we can observe that the armor stability improves by increasing the size of the armor units. And also the sand fill ratio also plays a crucial role in this armor unit stability. And it affects the deformability of containers, internal movement of sand, resistance against sliding, etc. And as per the literature review, there are different types of materials like polyester, polyethylene, polypropylene. Different kinds of materials are used to make these geotextile sand containers with different forms like geocells, geomembrane, geoform, etc. based on the construction application in those particular areas. And these are different kinds of geotextile, geogrids, geonets, and the different form of geosystems in which we opt or we choose. And as per Desnaike and Omersal 2012, they have given a damage classification criteria. Based on this, we will decide how the geosystems works in the real time in the sea conditions. Based on this, like first we conduct the experiment, and based on this experimental application of the damage classification table, we will choose how the overall structure stability withstands. In this, we can see that table that there is no damage condition, which means DC0, and there is incipient motion, which means DC1, and there is a minor damage, which means DC2, and the medium damage DC3, and total failure condition DC4. In the total failure, we can see greater than 40% of GSC bags are detached, and in DC3 we can see 20 to 40% GSC bags were detached. We say medium, and then we say minor damage when there is a movement of greater than 50% of critical layer GSCs and 5 to 10% of detachment we observe. And then incipient motion, we can see 10 to 50% GSC movement, and then less than 5% of detachment. And then in no damage condition, we can see less than 10% of GSCs are moved, and there are no detachment. Based on this table, we can say that how the damage criteria damage criteria is observed in the particular structure. And overall, by this literature review, we can see that these GSC bags are useful. Geotextile sand containers are easy in the, for the construction of breakwater or submerged reefs as we choose in the coastal and harbor protection structures. And the growing demand for these established guidelines and criteria are evident that the sand fill ratios, cross-section, design criteria, etc. are chosen. And then experiment studies are required to come with new design guidelines for further geotextile, harbor, or coastal protection structures also. And here my objective is to derive the optimal dimensions of a particular GS systems units with a sand as a filler material of an emerged coastal lake structure, and also find the stability of these sand-filled geotextile sand containers, and finding the damage classification of these geotextile sand containers made of with a coastal lake structure made of these GSC bags. And the methodology which I opt is finding the like going through literature review, and then calculating the wave parameters for this particular model, and then finding the and modeling the geotextile armor units, and preparing this model and conducting the experiment, and then finding the stability analysis after conducting the experiment with the different alignments, and then finding the results, and then choosing the optimum GSC configuration. And the model selection which I choose here is a 1:30, and the wave climate or the parameters which I've chosen is mangrove coastal conditions, which I opt as my department is in the Surathkal near to mangrove coastal conditions. And this we can see here prototype and the model, different incident wave height, different wave periods we can observe. And these geotextile sand containers where now I have chosen is a trapezoidal manner with a slope of 1:2 with a varying crest widths, and this crest width is equal to 2 lengths of 2 individual armor unit bags. And the wave height which I adopt is 8 centimeter to 12 centimeter, and the wave periods are of 1.2, 1.4, 1.6, 1.8, and 2 seconds, which I have chosen. Slope 1:2 as I told, and these are different dimension structures. These are different dimensions which I have chosen is based on the rubble mound application which I have opted here. And we can see here the different overall structural model which in which the bottom layer is the bedding layer is a 4 to 6 mm coarse aggregate, and the core is of 20 mm coarse aggregate. And then this primary layer is of 25 mm coarse aggregate. Overall, we place these bags over the armor layer, like top layer or this. And then there are 2 turbines placed on both sides, C side and the lee side. And this is the schematic presentation which I have done the experiment in the Flume laboratory in the National Institute of Technology, Karnataka, in which I placed this structure over here with a flume width of flume length of 50 meter length, in which we create the waves from the wave maker, in which they comes towards it over this structure over the seaside. And these probes are used to record this wave data, incident wave heights, as we can see here. The experiment data which here we recorded is incident wave heights and the different damage levels which we will record in our experimental procedures. And based on this damage level, we will see the different damage classification which I've shown out previously. Then this arrangement of bags and different elements which we can see here. Initially, we place the bedding layer over that core layer, over that secondary layer, or that armor layer which I have placed here. And these are the different elements which I have chosen now. Now overall is a single layer experimental work, in which first is parallel to the wave direction with a 50% overlap, and the parallel to slope of the structure, there is no overlap, in the 0% overlap. And the third one is Flemish army, in which both parallel to wave and perpendicular to wave direction can be observed. And this we can say the flowchart, in which different 3 alignments which I have chosen, and 3 water depths in the Flume laboratory which I have opted 40, 45, and 50 centimeter water depth. As we can see, the total height of the structure is 60 centimeter. Total height of the structure is 60 centimeters. So this is an emerged structure which I have opted here. So, and the different time periods which I have already told, and the different wave heights which I have chosen as per the angular coastal conditions. And after conducting the experiment, we can see when we plot the graphs of stability number and self-similarity parameter, we can see that the point for 45 centimeter water depth, which is shown here, is different damage criteria percentages, in which for the first one, we can see there is no damage. This is no damage conditions of about 32%. Like again, DC1 is of 24%, and 24% for minor damage. Major is around 20%. There is no failure condition observed in this 40 centimeter water depth. And similarly for a 50 and a 40 centimeter. In which the first graph, we can see that below the curve, we can observe there is a points in which the structure stability can be observed in 45 centimeter for the parallel to wave direction. And then 45 centimeter parallel to slope direction, we can see the curve, how it varies, and the points which were below the this curve are very less compared to parallel to wave, and then Flemish direction. And the comparative graphs for different alignments are in the first graph. You can see different water depths in a particular alignment. In the parallel direction, you can see there is no much variation for 40 centimeter water depth. But coming to 45 centimeter water depth, there is a variation which we can see. And then 50 centimeter, we can see much more variation for different alignments. In which overall, we can say that for parallel to slope direction, it is also 23.6% stable compared to 40 centimeter, 45, and 11.8% compared to 50 centimeter water depth, which I have told about this parallel to slope direction. And coming to the incident wave height and damage analysis which we have plotted here, we can find that different for different alignment, we can find the different incident wave heights based on these graphs, which we can see the stable part of these 3 alignments, in which we can calculate this incident wave height. In which I have chosen here shown here for 1.8, 2 and 2.2 time periods, in which we can see different incident wave heights. Overall, we can see like 2.2 seconds higher in this 50 centimeter water depth. For parallel to Flemish, it seems same compared to parallel to slope. And coming to 45 centimeter water depth, again we can observe for Flemish it shows higher incident wave height from the graph for a period of 2.2 seconds. And coming to 40 centimeter water depth, overall we can see for parallel to wave direction, time period of 2.2 seconds, 10.39 centimeter is the maximum incident wave height observed overall the three depths for a particular alignment. And these are the different damage classification percentages which we got after conducting the experiment, in which for the parallel to wave direction, we can see for three water depths for a different damage classification percentage we can observe here. As we note, they said the total failure conditions is observed at 4%, 12 and 20%. And coming to parallel to like Flemish, coming to Flemish, for these three water depths, the maximum total failure condition is about 28%. But coming to parallel to slope condition, we can see maximum total failure conditions are observed at 50 centimeter water depth. And coming to the next depth, it is 40 and 45. About 32% of failure conditions, total failure conditions are observed in parallel to slope direction. And then 50 centimeter water depth of 24%, like 45 centimeter for Flemish, and then 50 for 25. The least percentage of total failure conditions are observed at parallel to wave direction with about 40 for 40 centimeters. It is at only 4%. And for coming to stable in the damage classification, the total like no failure condition, it is observed higher for parallel to wave direction of 45 centimeter water depth with 48% of least like maximum no damage conditions are observed at parallel to wave, and least are observed at Flemish about 12% only. As now coming to conclusion, here I can say that overall from DC0 to DC4, like total fail, no damage to total failure conditions, we can see here being limit of permissible damage. Like from the graphs, we can see when the wave height increasing, there's significant increase in damage levels. And coming to this single layer, we can see the maximum is about for the parallel to wave alignment. We can see it is highly stable. As we can see from the incident wave height graphs, it shows like 10.39 centimeter. While coming to prototype, it is about 3.11 meter. Can be withstand for this parallel to wave direction for a water depth of 40 centimeter. And we can see like from the graph and experiment, parallel to wave direction structure is highly stable at a lower water depth than in higher water depth. And the next coming best alignment is Flemish alignment, and it is also sustained more for lower water depths, with like getting very less failure conditions. And parallel to slope is the least stable, as we can see from the incident wave heights or from damage classification percentage, it shows more failure condition. And coming to damage levels, the overall we can say parallel to wave direction shows about 44.58% higher from time when time period increases from 1.4 to 2.2 seconds. And the toe bumps which you place on both lee side and C side helps bottom layers of bags to withstand when compared to critical layers in the structure. And when the time period increases from minimum to maximum, the maximum wave heights on the structure increases by 22.1% to 25.42%. Or we can select gentle waves with longer periods are less damage to the structures. Like these are my references. Thank you.
Thank you very much, Vijay Charles. That was a good presentation.
Thank you.
We will now wait for some questions from the participants. You may place your questions in the chat box. Those who are attending through YouTube may also post their questions in the YouTube. It will be answered. Any questions? Looks like there are no questions. So I would like to thank Vijay Charles. Thank you very much, Vijay Charles, for a good presentation.
Thank you, sir. Thank you, sir.
This comes to the end of the main session. There is another session which has to start at 12:05. Where there will be quick presentations. So we will break for nearly 10 minutes, so to say. So we will rejoin. You don't have to log off. You can rejoin at 12:05 because I don't want to change the timings what has been given by the organizers, because people maybe would have planned to come exactly at that time. So we will start at 12:05 and we will have a break of 10 minutes. We can just stretch out. So please hold on. Perhaps the video, the recording could be stopped and restarted. Otherwise, it may be quite boring to have a session with nobody speaking.
Yeah, this is correct.
Hello, sir. I think we should start.
Another 3 more minutes, no?
Yes, another 3 more minutes. We will
Yes.
start at 12:05.
No, but as per schedule, it will be start by 12.
No, according to what they gave me, it is 12:05. It is, no, if you want, I can start, but the point is what they have given is Arkaprava ray is 12:05 to 12:10. Like that it is given.
So we can start because
Okay,
they will
okay
take
then.
time.
Okay, then that is fine. We can start the session now. Welcome to this last session of today morning. Today's presentations of 15 minutes are over. Now we have quick presentations of 5 minutes each. There are a few presentations, so we will start with the presentation by Arkaprava Ray on importance of tide gauge observations to identify the multi-scale sea level variability over Western Bay of Bengal. Mr. Arkaprava is available. You can start your presentation. Just 5 minutes. Don't take more time. You can keep your video on, no problem, and you can start the presentation.
So is it visible, sir?
You can put on full screen. It is visible, but you put on full screen, then everything will be fine.
Okay, sir. So I'm starting, sir.
Okay.
So hello, good morning, everybody. So myself, Dr. Ray. I'm currently a research scholar in IIT Bhubaneswar. Now I want to present my work for the first few months. And here, as you can see, that is the importance of tide gauge observations to identify the multi-scale sea level variability in the Western Bay of Bengal. First, I want to thank my co-authors, they are Samir Mandal and Saurav Sil. And really, I'm grateful to Ocean Society of India for arranging such a big
Arkaprava, your voice is not very clear. Could you speak closer to the microphone, and you can make this slide also full screen, please.
So I made the slide full screen, and I think my mic is also closer to my mouth.
Unfortunately, it is not coming on full screen. That is fine, but your voice is little bit getting garbled. It's not very clear. Okay, please go ahead.
Share has to be to the other window, not to the window. There would be 2 windows in presentation. So please share the screen on the other one.
Right, so one second. So is it full screen now?
No,
Not
but
yet.
you can start. We are running out of time.
You can go ahead. You can go ahead. Don't worry about that. Please go ahead.
Okay. So again, I'm just starting from fast. So I'm myself Dr. Probari. I'm currently a research scholar in IIT Bhubaneswar, and I want to present my work that is importance of tide gauge observations to identify the multi-scale sea level variability over the Western Bay of Bengal. I want to thank my co-author, they are Suren Mandal and Dr. Saurav Sil. And I'm really thankful and grateful to Ocean Society of India for arranging this beautiful conference to celebrate the Azadi Kambook also. And now I'm just coming to my points. And this, before starting, I must go through some introduction, and that is the tide gauge. What is the present status of tide gauge along the Indian coast? And as you can see, this is the green triangles which are indicating the location of the tide gauge, and it is almost 36 now currently available, and among which 31 tide gauge stations are installed by INCOS, which is a very good news for indigenous instrumentation and obviously technology. There are several ways to measure the sea level, but among which is presently in most of the instruments, there are 3 types of sensors that are being used: the radar, pressure gauge, and some kind of SAP encoder. So radar is just taking the reflection of the radio signals, and from that it can measure the sea level. And pressure is a bit complicated. SAP encoder is just digitize everything and convey that to satellite. So in the board there, as you can see, all the sensors are giving almost.
Arkaprava, your slide is stationary. You are not moving the slides, looks like.
Yes, sir. I'm in a first slide.
Okay. Okay.
So the radar is taken as the most efficient among all of them. And now just I'm coming directly to my result. So is the second slide is visible? That is identification of spatial and.
It is not
No.
visible. It is
No.
showing your introduction slide only.
Now it is identification of spatial. Okay, now this is okay. That is the third slide. This is now your third slide we are able to see.
Okay, sir.
Please go ahead.
Just I'm checking. Sir, is it changing, sir? I mean, I'm
Now-
changing here.
Now it has come to third slide.
So that is identification of spatial and seasonal.
Correct, correct. That's right. That's right.
Okay, okay. So there are four stations I took. That is Ennore, Kakinada, Paradip, and Garden Reach along the east coast of India and west coast of Bay of Bengal. So from that, as you can see, the spatial. If you look at the spatial pattern, it's just gradually increasing as we are moving from south to north and from Ennore to Garden Reach. So there are for two different constituents. There's the semi-diurnal, that is M2S2, and for diurnal for K1A01. The result is quite similar. And for shallow water constituents, that is M4 and MS4, the gradual increasing pattern is not being shown, but the Garden Reach, as you can see, the amplitude, or you can say the tidal height, is abruptly high, and one of the biggest reasons is the shallow water bathymetry in the northern coast, and the Garden Reach, the tide gauge is very much inland, and obviously coastal geometry has its own impact. And now I'm coming to the seasonal wave, which is the right hand side figure, and as you can see here, also a gradual increasing pattern as we are moving from pre-monsoon to post-monsoon, that is March, April, May, June, July, August, and September, October, November. And this is December, January, February. So as we are moving from pre-monsoon to post-monsoon, this is increasing. So what can be done? And this is shown for Paradip and Kakinada, but not that much shown in case of Ennore. So what may be the possible reason? And to find out that, we just plotted the Brand-Weissela frequency, which is a good representation of the stability in that water column. And as you can see, in Paradip, it is very much high due to a very good amount of freshwater flux. Kakinada is also that much higher, but in Ennore it is not that much higher. So what is the connecting dynamics between these two? So maybe there is a very good amount of stability is present. That's the reason why particle mixing is not that much present. So tidal energy is not converted into that eddy mixing thing, and that's the reason why it completely restored and just converted to increase the amplitude of the M2, which is the most convincing and major constituents of tides. Now I'm just coming to the next slide. So is the slide visible? This is the fourth slide. Hello, sir.
We still see third slide.
Okay, you explain, please, because time is running out. You can explain the fourth slide. We are not able to see it, unfortunately.
Okay, sir. So,
Yes, we can see it now. Please go ahead. Arkaprava, please go ahead. We can see the fourth slide. You are muted now, Arkaprava. Please unmute and speak.
yes, sir. Can you hear me?
Yes. Please go ahead. It is time is up. Please go ahead fast.
Yeah, sir. Sorry, sir. Identification of the non-tidal signals from the tide gauge stations that we want to focus, and in the western coast of Bay of Bengal. For that, we discussed the tide gauge, which is too much inland. Otherwise, we just made a wavelet analysis of the residual data. Means the tide part is just been discarded. And as you can see, for all the three stations, that 90 to 120 days signals is present for all the stations. But for Ennore, the 60 to 90 days signals, as you can see in the left-hand part, the periodicity. So that is quite present and with a significance, statistically significant enough. And for Paradip and Kakinada, this is present but not that much good enough. And also there is a rate patches found in the mid of the year, which is near around monsoon in case of Paradip and Kakinada. So these three can be resembled with or can be managed with like Kelvin waves. This is 9 to 120 days, 60 to 90 days maybe resembled with MGO, and 10 to 20 days maybe quasi-biweekly oscillation. To clarify our intuition, we just plotted a spatial correlation between the SLA of Paradeep and 5 locations, that is L1, L2, L3, L4, and L5. In that case, you can see a very good indication of the coastally trapped Kelvin wave, and we made a lead lag correlation as well. As you can see, the auto correlation with Paradeep, obviously, it got 1 in the 0th time, but for L1, it is found around 100 days. L2, it is around 60 days. L3, it is 45. And L4 it is 4 days, and L5 it is obviously in the negative sense. So obviously these are 100 to 120 day signals, and which can be captured from the tide gauge.
Please wind up now, Dr. Prabha. Please wind
yes,
up.
Sir, it is done. Yes, sir, it's done. So our intuition is quite right. So now it may not sound, my complete presentation may not sound that much technical, but I wanted to focus on the importance of the indigenous instruments and the technology. And I'm really thankful to INCOIS for providing me data, and IIT Bhubaneswar for helping me to conduct this research. Thank you, sir.
Thank you very much, Mr. Arkaprava Roy, for the very lucid and quick presentation. We will now move on to the next presentation by Merin CA, effect of internal tides on acoustic propagation in the Central Arabian Sea. Mr. Merin is available. You can start your presentation. Merin, please. Are you able to hear? Merin, please start your presentation. Merin, you can share your screen. You are sharing. Yes, now we can see. Put in full screen and start the presentation. But we are okay. It is visible. Please go ahead. Please start. Merin, are you able to hear? You can start your presentation. Merin, can you see? Sorry, can you hear? Merin, you have some technical problem, looks like. Are you able to present? You can start. We can't hear you. Okay, it looks like Merin has some technical problem. We will come back to him later. We will go to the next presentation. Next presentation is by Arya Thomas. Arya Thomas, you are available online? Arya Thomas is there?
But I think Arya Thomas is not there.
No, Arya Thomas has not yet joined, I think. He's not
Okay.
online.
Okay, then we will go to Aditya.
The Merin, she is online, but not yet, not able to hear.
Merin, there is some problem. It can be sorted out, but let us finish with Aditya. He is already online, and we will come back to Merin after that. Yeah, Aditya, can you share your screen and start presentation?
Yes, sir, sure.
Please go ahead.
Yeah, can you see my screen, sir?
Yes, we can see, but you have not sent the abstract to the organizers, looks like.
Yes, sir. Like, I mean, I sent it like a day after the
Okay, fine.
So
Please
that's
go
why.
ahead.
Yeah.
Please go ahead with the presentation.
Yeah. So, hi everyone. I am B.A. Didya, doing my PhD at the Center for Atmospheric Sciences, IIT Delhi. Today, I'm going to give a short presentation on the internal tide energetics in the Andaman Sea. So internal waves are subsurface gravity waves that occur inside the ocean at the interface of different water densities. And internal waves of tidal frequency are called internal tides, which are of the main interest in our study. We computed the barotropic to baroclinic energy conversion by integrating the product of density perturbation with barotropic vertical velocity. Since this is a 5-minute presentation, I'm not going to present everything. So just some of the highlights. So a 3-dimensional MITGC model is used in our study, and the simulations are carried out for March, June, September, and December 2017. The initial temperature and salinity fields are derived from ORES5. Since the semidiurnal tides are the predominant tidal constituents in the Andaman Sea, the boundaries are forced with M2 and S2 derived from TPXO 9.2, and this is our model domain. So coming to the experimental design, the following set of simulations are conducted to understand the seasonal variability of the internal tides in the Andaman Sea. Here, in the first set, the realistic simulations, the temperature and salinity fields are initialized for the respective months from ORES5, and the stratification here varies from location to location. The tidal forcing is also given for the respective months. So the comparison between simulations in this set can help us understand the seasonal variability of internal tides in the Andaman Sea. Since the amount of energy conversion from barotropic tide to baroclinic tide mainly depends on tidal forcing and stratification along with the bathymetry, we conducted some additional sensitivity experiments. So to understand the effect of tidal forcing, here the stratification is set to constant, and we use the annual mean profiles from ORS5, and the barotropic tide is varied. And to understand, similarly, to understand the effect of stratification, we kept the barotropic tide as constant to September, which is the maximum in our study time period, and we changed the stratification by giving a uniform stratification model domain model averaged stratification for the respective months. I'm skipping the validation of model simulations because of time constraint. Coming to the results, like here we compare the baroclinic tidal energy budget between different seasons. So for analysis, we divided the model domain into 6 subregions. First one is Preparis channel, 10-degree channel, Sombrero channel, Great channel, and this is the Northeast Andaman region, and this is Southeast Andaman region. The blue numbers inside the boxes, they indicate the amount of energy converted from barotropic tide to baroclinic tide inside the box. The purple numbers indicate the baroclinic dissipation, whereas the red numbers along the boundaries, they indicate the amount of baroclinic flux propagating out of each box. When we compare the internal tide analytics, we observe different trends in different subregions. For example, the energy conversion in Preparis channel and 10-degree channel has increased from March to December and slightly decreased during March to December. But if you observe in the Sombrero channel, where maximum energy conversion is seen, there the variability is really negligent. And if you observe Great channel, the maximum energy conversion is seen in September. But for the Southeast Andaman, it is seen in June. So it's like a different pattern is observed for different subregions. And since as I mentioned, since the energy conversion is mainly dependent on tidal forcing and stratification, so we conducted the sensitivity experiments first for tidal forcing. Here we observed a a more clearer pattern. And like in almost all the subregions, we found that energy conversion has increased from March, June to September, and then slightly decreased in December. So the maximum tidal forcing is seen during September 2017. Next, coming to the effect of stratification, here again we observed different patterns in different subregions. For example, in the 10-degree channel, the maximum energy conversion is seen during December and June. But in Somreru channel, again, the variability is very less. It is almost constant. In other regions, like generally in the Northeast Andaman and in Southeast Andaman, the maximum is seen in September. So I mean, these are the mean profiles of temperature, salinity, and buoyancy frequency that are initialized for this set of experiments where we studied the effect of stratification. And if you observe the buoyancy frequency in the panel C, you can see that within the top 125 meters, like maximum buoyancy frequency is seen during September, but below 125 meters, maximum stratification is seen in December and June.
Aditya, you can wind up, please.
Yeah. So the main conclusions from our study is that like different regions in the Andaman Sea, they display different type of seasonal variability in the internal tide energetics. And unlike South China Sea, which is one of the other regions where large amplitude internal tides are observed, there tidal forcing is the predominant factor that controls the seasonal variability. But in the Andaman Sea, we have seen from the simulations that both tidal forcing and stratification seem to be playing an equivalent role. So thank you for this opportunity, and I'll be happy to take any questions.
Thank you, Aditya, for a big presentation. That was really good. We have to move on to the next presentation, which was left out. Mr. Merin, are you there? Are you able to join? Merin looks to be not here. Merin came and he could not join, is it not, earlier? Now he is not to be seen at all. Is he in the waiting room or somewhere?
If we have time, maybe we can wait for a minute or so, because this is now the last presentation.
Yes. We will wait. Both that Arya also is not here, is it not? Both of them are.
This is also not there. Yes.
Oh. Any alternate contacts the organizers have got to contact Merin and check what is happening? Any possibility is there? Merin, you are there? One number has come, joined here. Is that Merin?
Am I audible now?
Very feeble. Is it Merin?
Yes, sir.
Your voice is very feeble. We can hear, but very feeble.
Hello.
Yes, somewhat better now. You can start your presentation.
Hello everyone. Himadri CA. I'm a junior research fellow at NPOL. I'm here to present the work carried out on internal waves, the effect of internal waves in the acoustic propagation in the Arabian Sea area. In order to, our primary objective of this work was to identify the internal tides and its acoustic and its effects mainly on the acoustic propagations. So for this we have analyzed the ADCP and CTD data. Also we have tried to compute the transmission loss and its variability.
Marin, do you have a PPT presentation? Do you have it already sent to the organizers? Then they can maybe show it. Do you have it?
Sir, is the screen not visible?
No, screen
Yeah,
is
your
not,
screen is not visible.
not visible.
Merin, your presentation is with me. Can I share?
Yes, the next presentation
Hello?
by Darsana.
Merin, your presentation is with me. You shared yesterday. Can I?
Yes, sir. I have emailed it to.
Yeah, I have that. I am sharing it. You don't have to share now.
Please share it, Arnab. I mean, let us
Yeah. I'm
move
sharing
on.
it.
Sir, how will I access it?
No, you can just say
you'll see.
next slide. Next slide you can tell, and Arnab will move the slide.
Yeah.
Your slides are not visible, so you screen share your screen.
Sir, can I continue?
Yeah,
Just
1 minute.
1 minute.
Sharing
Let
it.
him share it.
Yeah, it's now sharing.
He has shared it. Now you can continue, and whenever you want to change the slide, you tell next slide, please. Now we are seeing the first slide.
Okay.
Yeah, sharing it. 1 minute.
Please go ahead.
Yeah, please go ahead.
Sure, sir.
Are you there?
Hello.
Please go ahead.
I am presenting here the work carried out on the internal waves and its effect in the acoustic propagation in the Arabian Sea area. The primary objective of the study, sir, next slide, please. The primary objective of the study is to identify the
You can go to next slide, please, Arnab.
and its presence in the Central Arabian Sea area. After identifying it from the CTD and the ADCP data, we study its influence in the acoustic propagation. This will contribute to the detection a detection of the targets. Next slide, please. The data that we have studied analyzing here is from the WHOI mooring array for the duration of April to July, that is the pre-monsoon season. In the Central Arabian Sea location. Here the mooring is up to the depth of 300 meters, and the temperature and salinity data from the CTD is mostly used to calculate the sound speed and its fluctuations, and the ADCP data was used to calculate the velocity spectrum. The images clearly indicates the array deployed and its sensor distributions. And for this calculation, we estimated the sound speed and its fluctuations. From this, we were able to identify the sonic layers and the channels, and followed by the thermocline. And the sound speed and the sound speed fluctuation was also calculated according to these formulas, and the buoyancy frequency or Brandweiser frequency was which give which is the quantification of the stratification of the water column is also estimated. The vertical velocity spectrum was calculated from the ADCP data. We could also calculate the transmission loss We also had a numerical calculation on the transmission loss for a range dependent and range independent cases. Here we explain the variability in the sound speed profile in the season. We can find the sonic layer of 20-meter depth in the initial figure gradually increases up to 50 meter with a channel just above the 100-meter, followed by a thermocline. The end value is also represented by the black line, indicates the Brand-Weisshaler frequency, which shows a critical peak at the thermocline depth of 10 to 12 cph. The vertical velocity spectrum we calculated from the ADCP measurements for a 60-day duration data clearly shows the semi-tidal frequency, which indicates the presence of internal waves of the frequency component of tides. And the diurnal and semi-diurnal and quarter-diurnal frequencies were also visible from the vertical velocity spectrum. A similar result was observed in the N frequency spectrum analysis. Our observed values along with the calculated values are tabulated. So next slide, please. From the calculated estimated sound speed profiles, we ran a range independent acoustic propagation. And these are the transmission loss calculated for typical source depth of 50 meter, 100 meter, and 150 meter for a source of 600 hertz frequency. The numerical model used here is Gaussian beam ray model named seat ratio, and the transmission loss at the origin is around 40 dB, which actually critically increases within the first 5 kilometers and settles to a value of 80 dB with fluctuations. We also constructed a range-dependent sound speed profile, assuming that the internal waves travels at a speed of 50 centimeter per second, which displaces the sound speed profiles for a range of 48 kilometers, and estimated the transmission loss in that case also. Next slide, please. Here
you have to wind up now. Time is up.
Here is the this is a transmission loss, and we can see there is a critical difference in the transmission loss that suggests that there is a presence of internal waves, and it contributes to the acoustic propagation critically. So next slide, please. And this is the difference in the transmission loss at a depth of 20 meters for different source depth of 50, 100 and 150 meters. And the difference we critically find is fluctuating over the range after a 5 kilometers, and it's between 20 and minus 20 dB. So this might be probably induced by the internal wave effects. And from this study, we could conclude that there is the presence of internal waves of of the tidal frequency, and that the presence of internal waves can cause the long range detection suffer. So next slide.
Please go ahead. What happened?
Sir, thank you. I would like to conclude now.
Okay. Thank you very much for the brief presentation. With this, we have come to the end of this session. Let me thank one and all the speakers who have given a very good presentation, starting from Dr. Ramanamurthy, who gave the invited talk, followed by the various talks, the performance of C Profiler by Gautaman. Then Raju made a presentation about the numerical study of wave transmission, followed by the talk on seasonal sediment characteristic at Kandla. It's a practical work by Nandini. Reshma George presented the physical model studies on stability of breakwaters, basically an experimental work which was done at NIT. Tapala Vikrant he has done a lot of work in the ocean observatory and transmitting the data. He has done it at Bhavanapadu estuary by using Internet of Underwater Things. This was followed by the presentation by Akhil Varghese on variability and accuracy in the estimation of sound speed in Indian waters. He has shown how the accuracy could be improved. Then Vijay Charles explained about how the geotextiles, which are put in a particular manner with various coarse aggregates, how it could be used for coastal protection. This was followed by rapid presentations by Arkaprava Roy, Yaditya and Merin. Quickly they presented various topics, and Arya Thomas, are you there again? Because we are missing one presentation which has to be informed to the organizers. I hope that would be done, because normally in IEEE conferences, if you don't make a presentation, then that will not come in the sorry, IEEE Explore or the website. It will not come. So I'm not sure how Osicon standards are, but please make note that this particular presentation was not done. And I have already sent the evaluation to Dr. Pramod. I would like to thank Dr. Pramod and Dr. Arnab for providing all assistance to hold this meeting, this session successfully. Let me thank the organizers of Osicon, Dr. Ravichandran, and all others for giving me an opportunity to chair this session. Thank you very much. Over to Dr. Pramod.
Yeah, so if we all, thank you, sir. Thank you very much. And maybe at the end, if everybody can put their cameras on, we can take a screenshot. It's like a picture which we would take that we attended this conference, and I will share it with the organizers. So I request everybody to please switch on your cameras so that I can take a screenshot. So I see only 3, yes. Yeah, Aditya, and anyone else would?
Others have left, looks like they are not there. Ramanamurthy and others who were in the first session, they are not here.
Okay, so I will say at the count of 3, cheese, and we'll take pictures of 4 of us. Okay, 1, 2, 3, cheese. Thank you, sir. Thank you very much.
Thank you very much. So bye. Take care, all of you, during this COVID time.
Thank you very much.
Bye.
Yeah, thank you very much all.
Thank you. Thank you. Bye.
Thank you. Yeah, bye.
Good afternoon, sir. Please unmute your mic. Kurian, sir.
I have unmuted.
Yeah. Good afternoon, sir.
Audible? I am audible, right?
Yes, yes. Perfect.
Okay.
So, sir, are we going to judge for any oral presentation? Like
no.
No.
We are not.
Okay.
Our coordinator is there.
Yeah, he'll be coming. He should be here by another 3-4 minutes.
Okay.
That's what he told. So
Suprit Kumar, isn't it? Suprit Kumar. Yeah.
Yes.
So,
just a quick one. Can I upload my file and see whether it is okay or not, please?
Hello, welcome, Dr. Matthew.
Thank you.
Okay.
I just want to share my screen.
Yes.
And just want to make sure that it is working okay. Full screen. Is it full screen visible?
Yes.
Okay, good.
It is visible. Good.
Okay, then I stop share now. Okay. And my video will be okay.
So I think, Tripadi, what you are discussing, we are not going to have any sort of evaluation or anything, right?
Okay.
Because there is no contest paper from our side. So,
Right.
you know, otherwise we should have, I just had a look at the abstracts and I felt that, you know, you don't have to, there is nothing like, I felt like that. Anyway, we can decide if there is anything outstanding and all, we can give a recommendation. That is what they are telling.
Sure.
But, you know, there is some problem involved in giving, you know, like awards to those who are not opted for it. Because we had already announced in the beginning itself that those who want to be considered have to give their names. So, so people are given their names and it goes without saying that we should consider only them, not the other people.
Okay.
So that is it. So I think our program will go like this, that, you know, like you will introduce me, then I will take over, then I will introduce Dr. Joseph Matthew. And then I think we will, after that, maybe a few questions. And that will be followed by maybe some sort of, you know, a plan we will announce. Like 7 papers are there. So 7 papers into 15 minutes. So each paper, 12 minutes for presentation, 3 minutes for the oral. So you can help me that you follow the timings and all. We should warn people. I think there must be something in the system itself, isn't it? To warn.
Yes, usually they give a stopwatch which is appearing on the screen. So I think
screen. Yes. That is it.
So Sir Suprit has agreed to kindly introduce you. So I think you should be there. Morning we discussed actually.
Oh, no problem. So, yes. No problem. Over. Yeah, that's okay. So what is your specialization, Sharad?
So basically I'm a marine biologist, biological oceanographer.
I think these things are recorded, isn't it? So I think...
yeah, no problem. So I work on phytoplankton production and biooptics in Southern Ocean, as well as in Arctic. And so before I joined here, I was in Japan. I did my DSc from there.
Oh,
and last 9 years I'm with NCPR.
Okay, NCPR. Okay, very good. And what about Suprit's background? What is he?
I have never met him before. It looks like he's from engineering background. And
okay.
Like he's from Incois. And
yeah, he's from Incois.
I never met him. Today morning I found out his mobile number.
Yeah, we are all meeting virtually only. Thanks to
the website. And then I called up him and then talked to him that how we should proceed. And so that's what.
Okay, yeah.
I'll just message him.
Yeah. Okay. So for a short while, I think you will switch off the video.
Yes. Sir, I have a query actually. In the previous sessions, since nobody is there now, no participant, I think, yet. Actually, they were asking one or two recommendations from each speaker, which need to be submitted to the organizing committee. So, do you have planned something like that? Then we can ask after the presentation, like we can send an email to them to provide one or two line recommendations based on their studies.
Okay, well, that's fine. That's fine. Or is there the PPT itself we can take?
Actually, yesterday was my presentation, and the session they asked me similarly that what do you think, how you should proceed in future work? Like, so if the presenter gives it, it will be always good. Like,
yeah, it will be good actually. You know,
this is not for the discussion that we have to submit to the organizer actually, for the report.
That's fine. That's fine.
Okay, sir.
Then you can send a mail right now. You know.
No, sir. After presentation, we'll do that. No
yeah,
problem.
yeah. After presentation, also you can send a mail to them, and they can do it. That's fine.
He's not able to join. I'm waiting in the lobby.
Okay. Actually, that phone number should have been. You don't have his phone number? Do you
I have his phone number. I'm calling him.
Then it's all right. Yeah. Okay, I switch off the video for the time being and unmute.
Hello, Suprit. Can you hear me? Yeah. Okay. Yeah, please unmute your mic. Please unmute your mic.
Can you hear me now?
Yes, it's clear now.
Okay, fine. Finally it worked.
Okay, fine. But the voice is echoing. It looks like two systems are open side by side, probably.
Now it's okay?
Yeah, it's perfect.
Now it's okay?
No, it's still echoing. Maybe you switch off the laptop or any other devices through which you have logged in. We are approaching, time is running out. Please do it faster.
Yeah, here it is switched off.
Okay, now it looks fine, I think. Can we talk a little bit more? Yeah, then we can check.
Yeah. So now
Yeah.
can you hear me properly?
Yes.
Yeah. Okay.
Yeah, there is no echo now. Yeah, correct. I'm yet to see any participants. Our invited guest is already there.
Hello, Suprit has joined.
Yes, sir.
Okay, hello, Suprit.
Hello, sir.
I'm Kurian here.
Yes, sir. Good afternoon,
Okay.
sir.
Can you just put your video? Just I want to see you. We are seeing for the first time.
Can you see me, sir?
Not yet. I saw Sarath and we talked, but I'm yet to see you.
Okay. My video is on, sir.
No, I'm not seeing.
I will stop and on again.
Okay.
Dr. Sharath, can you confirm you can see my video?
Yeah, I was able to see you actually, but not right now.
Okay.
Yeah, I can see you now.
Yeah.
Sir, probably you have to click on the arrow mark so that you can switch, like slide between the windows.
Okay, okay, probably. Okay.
At a stage, you can see only 4 videos.
Yes, I'm seeing.
Yeah.
Right, you are right. Okay, hello, Suprit.
Sir, I have seen you. You have come to Goa many times with some PhD thesis examiner. In my friends,
Okay.
I have seen you. I worked in Goa, NIA Goa.
Okay. Oh, that was your friend, huh? Okay, that's right.
2-3
Where
friends.
is he? Where is he now? I forgot his name.
Dr. Manoj, I guess you were there?
Yeah.
He is in Middle East, sir. He is working
Middle.
working for government of some Saudi Arabia.
Okay.
Some government job there.
I think we are approaching time now. I think we should go ahead. Just 1 minute only.
Okay, sir.
Am I audible?
Yes, you are audible.
Thank you.
Hello everyone, I'm from Virtual MNC. May I request you to please start the session? We are live.
So, Dr. Sharath, we have the participants.
No, let's go ahead because our guest is already there, so they'll be coming later on. So
Yeah. We should maintain the time. Let us go ahead.
Okay.
They'll be coming.
Okay, sir. So, good afternoon, everybody, and warm welcome to all of the delegates, the presenters, our guest speaker, and chairman of the session, technical session number 12 of Ocean Engineering and Technology of Osicon 2021. Myself, Suprit, and my colleague, Dr. Sharath from NCPR Goa are the two coordinators of this session. Before formal commencement of the session, I would like to introduce the chairman of this session, Dr. N.P. Kurian, an eminent oceanographer of our country. Okay, Dr. Kurian is presently serving as one of the vice presidents of the Oceans Society of India. Okay. Dr. Kurian served as a director of National Center for Earth Science Studies, which is called NCES, Ministry of Earth Sciences. He is a coastal oceanographer with 45 years of research experience. Dr. Kurian had his PhD from the Cochin University of Science and Technology and a PG diploma in remote sensing from the Indian Institute of Remote Sensing. He started his career in 1975 as instructor in oceanography, College of Fisheries, University of Agricultural Sciences, Bangalore. He joined as a scientist in the erstwhile CES, which is now NCES, in 1980, and he has been working there till he superannuated in 2015. He has implemented several research projects in the field of coastal processes, sediment budgeting, and shoreline management. He has been a member of several technical and advisories committees of different institutions.
Dr. Kurian has 3 books and edited volumes to his credit. He has published more than 90 research papers in international and national journals. He has guided 6 students for PhD in addition to guiding several students for their PG programs. Now I may kindly request Dr. Kurian to formally start this session. Thank you, sir.
Thank you, Supreet. And it's my turn to welcome Dr. Joseph Matthew, who is the invited speaker. Good afternoon, one and all. It's my privilege and honor to introduce the invited speaker of the session, Dr. Joseph Matthew, who is a coastal engineer of international standing. I hope I am audible. Am I audible? Okay. Since I am aware of his work for the past 3.5 decades, I am in a position to give more details on his brilliant career. Dr. Matthew has 2 PhDs, the first from the Cochin University of Science and Technology under Dr. M. Baba, who is an eminent coastal engineer, and the second from University of Waikato, New Zealand, under the guidance of Professor Terry Healy, who was also an eminent coastal scientist. Dr. Matthew was molded into a coastal engineer of international fame by his association with Professor Kerry Black, who is a well-known mathematical modeler and coastal engineer. The team has implemented several coastal projects in India, New Zealand, Australia, Europe, US, and Indonesia. As you are all aware, the coastal processes vary drastically from the tropics to subtropics. The exceptionality about Dr. Matthew is that he has consulted and researched both tropical and subtropical regions for decades. Dr. Matthew's recent coastal projects include design and implementation of 10 coastal protection projects in Karnataka under the Sustainable Coastal Protection and Management Program funded by ADB, design of 6 coastal protection projects in Maharashtra for the Maharashtra Maritime Board, and a coastal protection project in Pondicherry for NIOT Chennai. He was a key member of a recent ADB technical assistance project, which developed reference manual on climate change adaptation guidelines for coastal protection and management in India. I hope you must be having some exposure to this document, which is a published document. Dr. Matthew has published several papers in national and international journals, in addition to being the co-author of many technical reports. With these few words of introduction, I request Dr. Joseph Matthew to come forward to make his presentation. Dr. Matthew, you have got 25 minutes time for your presentation, and we will have a discussion of for 5 minutes. That is what we have in our plan scheme of things. So, Dr. Matthew, please.
Thank you, sir. I will try to keep my time within that 25 minutes. I hope my screen is clear there now.
Yes.
So today I'm talking a little bit about coastal process and coastal challenges under climate change. Reason for that one, you've seen the recently published IPCC report about climate change. It says very clearly climate change is widespread, rapid, and intensifying. In terms of coastal area, the report says contributing to more frequent and severe coastal flooding in low-lying areas and coastal erosion. So the extreme sea level events that previously occurred once in 100 years could happen every year by the end of this century. This is pretty scary and really important for our planning and scientists and engineers to sit together and plan how we can manage our coast under coastal climate change. So our management has been different, and for the last 50, 60 years, we have been managing our costs in different ways, because many of our coasts are naturally prone to erosion with low-lying muddy or sandy back shores. And under climate change, these low-lying areas will be affected significantly, including the dunes. And unfortunately, a lot of our coastal constructions on the sand dune itself. So are we safe? Adding to this one, the present day natural hazards like cyclones and fires, we have this exacerbated influence by sea level rise. And if you check the coastal population of India, East Coast thickly populated along the river deltas, low-lying areas, and population density more than 2,000. All along Kerala coast, more than 2,000 persons per square kilometer. And in Mumbai, Gujarat, many other places. So these are low-lying areas only, and the dunes are different. According to a ADB publication, a recent 2017 publication, in 2020, India's population in the low-lying areas were something around 64 million, which is going to be something around 216 million by 2060, not far away. And at the same time, sea level is rising and coastal storms increasing. Are we prepared to manage our coast? The primary question is, does coastal protection have to be done differently under climate change? Can we continue our present method of coastal protection? Will the existing structures become redundant and need to be replaced, like sea walls? And the legal things, our CRZ line, 50 meter, 200 meter, 500 meters, what is the relevance of that CRZ line under sea level rise? And trade-off between human safety and land protection. Then whether the beach will erode or simply adjust if one exists. And shortfall in economic impact assessments. Most of our assessments are based on the present conditions and present infrastructure on our coast. Have we considered the future development plans? And whether there's a recipe for the universal protection, can we go with the one single solution for our entire coast, or will it be site-specific? And if there's 1 meter or 2 meter sea level rise, whether our shorelines will be protected. Let us check some of the facts. This is significant wave height of Trivandrum coast for the last 40 or 2005 to 2019. And wave height increases during monsoon time and low wave height during non-monsoon. And there's periodicity there and a predictability there. And some episodic events, but still it was okay. And likewise, wave direction and period responded the same pattern as wave height. However, in 2017, December, late November or early December, we had the cyclone Oki, a peak one. The importance of that one was, it was just after the monsoon or end of the beach rebuilding period. And 2018, another cyclone. We take 17, 18, and 19, every year one cyclone, either before the monsoon or after the monsoon or during the monsoon. What impact these cyclones on our coast? So we do have long, dry, and wet beaches, wet wave climate, so that the beaches can respond to this wave climate or the dynamics. So it responded to monsoon dynamics and made it in an equilibrium situation according to the monsoon waves. And it responded to the low wave climate according to the dry period. However, if cyclones are going to happen after the monsoon, the beach is going to struggle quite a lot. And the history of cyclone events over Arabian Sea, of course, I'm concentrating more on the Arabian Sea because of the conference on the West Coast, but people don't misunderstood that I'm not considering East Coast. So Arabian Sea, since 1800s, there's a tendency of increase in the number of cyclones since 2010. And this record is only up to 2020, and there is more to come. And more importantly, the maximum number occurs before the monsoon or at the beginning of the monsoon or in the post-monsoon. So this has huge impact on the beach rebuilding or erosion process. So if you compare with the other places like the east coast of India or the Australian east coast, Gold Coast in the southern hemisphere, or California on northern hemisphere, they have a separately different wave climate than our west coast of India. West coast of India is pretty unique. Even if you compare east coast of India, they have uniformly about 1 meter wave height throughout the year, except during the northeast monsoon time, which is also associated with the cyclones. And their climate is more or less similar to the subtropical weather. And the subtropics, there's a periodicity every 2 or 3 weeks, some big waves, then calm period, then big waves, but periodicity there. So their summer winter period totally different from our wave climate. The impact on our coast, particularly post-monsoon or pre-monsoon, will be huge because of our waves are too small after the monsoon or after December. So beach rebuilding process will be really, really difficult. So the impact of climate change and frequent and intensive cyclones will be much more on our coast than any other coast, than the east coast of India, than the subtropics. So we do have much better understanding about our process. Can we make stable beaches under climate change? In a not normal situation, erosion accretion has been seasonal, and which is only a redistribution of sand from the upper beach face to offshore, then in the post-monsoon or post-storm back to the beach. So it was only redistribution, and surf zone plays a major role in that activity. However, now we have a line where the maximum erosion, we do have an erosion profile, and we have a safe zone called XG. The science should study what is the probability that an erosion profile XC moves landward than XG under storms and sea level rise. This is not only for the low-lying areas, but other areas as well, because our infrastructure in the coastal sector is huge and coastal population density very high. So normally people take Bruin's rule for this beach response and sandy beach response compared to sea level rise. Whether it is applicable for our coast, it's a two-dimensional model, assumes the upper beach is eroded and moves landward, and the sediment eroded from the upper beach is equal to that sediment deposited on the near shore bottom. Is it going to be the same for our coast? And it assumes that no net sediment exchange between the active profile and the outer shore face. Otherwise, surf zone still maintains that exchange process, and no net lateral or longshore sediment transport. So two key things we need to consider here. One is the extent of the depth of closure. Because of the cyclones, whether our depth of closure will go further shoreward or seaward, if the sand goes beyond the depth of closure, whether our beach rebuilding process will happen naturally, or what fraction of the sand will come back to the beach to give a stable beach. In the net longshore sediment transport, how far the sediment will go, and do we need to redefine our sediment cells? We do have quite a lot of problems with our coast, primarily human interference on sediment movement. And migration to the coast is also really, really significant in the last 10, 20 years. Therefore, our dunes are subject to increasing pressure. And there's a mismatch between climate change and development goals. Because of squeezing effect, our dunes are more susceptible to storm erosion. So we take the example of Goa, because the conference is in Goa, and we assume that headland beaches are much more stable than open coast. Here's an example of Kalingat Beach, which is 7.5 kilometers, bounded by 2 headlands. Has been really safe, but there's a small ship of 230 meters grounded in the near shore in 2000, but that created huge erosion in the southern part. A small ship of 200 meters sitting offshore was enough to erode all the southern part, which means if you do any small things in the coastal area, that has huge impact on adjacent coast. So we talk about sediment cells and the importance of sediment cells. Whatever your activity within a sediment cell will affect the entire area. So our measures, coastal protection measures, should have a really good understanding about the longshore transport and the surf zone dynamics. Otherwise, these sort of failures will happen. So once you remove the ship and the beach is back to normal. So nature gives us an example. If there's any small interference, definitely it will have an impact on the sediment cell. So we have been considering particularly the monsoon direction for our coastal protection. So, or the westerly waves for west coast of India. This is the primarily west quadrant. And our sediment transport calculation, longshore sediment calculation using different formula in different magnitudes, no consistency, because all these formula have been for subtropical environment, not for our monsoon beach dynamics. We need to improve our understanding about the longshore sediment transport, even though the directions are same, but the magnitude too different. So we use different formula. We don't know which one is the right one. How do we approach that one? Now we have the problem of multiple directions. Waves or storms can develop from multiple areas, sometimes totally opposing. Which one is the dominant for longshore sediment transport? The first peak or the second peak? The first peak may be coming directly to onshore, not contributing to the longshore sediment transport. But on the other hand, the second peak with the lower energy can come at an angle and create maximum longshore sediment transport. Should we go in the spectral method for longshore sediment transport? Now, cyclones are coming from north, south, east, west. And our assumption about coastal protection for westerly quadrant has changed. There's significant change in the wave direction over a very short period. It's coming from the southwest or northeast and monsoon direction. This is cyclone Oki. It was consistently around 220, which is during non-monsoon time from the south, but gone to 334. That is this direction. So our coast is really struggling to adjust or get an equilibrium with this new situation. Sometimes like this 2019, early October or late October, we had Cyclone Maha from south to north. Then before that cyclone reaches or landfall, there's another one from east to west, and coast is struggling too much. And the occurrence of these cyclones during the beach recovery period, and which resulted increase in the strength of the wet return flow, which normally occurs during storm events and the monsoon time. That's why our beaches erode or sand redistribution happens. Then the cyclones delayed the post-storm beach recovery. This is really important for us, how far the sand will go offshore, where we should define our depth of closure, what fraction of the sediment will move north or south, which sediment fraction or which wave direction we should take for our sediment calculations, longshore sediment calculations. Impact of these ones, beach lowering, really significant. If there's seawall, then end effect of the seawall, up coast and down coast erosion depending on the nature of their coast. Overtopping very common during our cyclone period, all along our coast, and inundation of the low-lying areas. When the cyclone is from south to north, our northern part of the structure will erode, and when it is from north to south, southern part will erode. So our protection so far has been for cross-shore transport to protect the land, but it is no more valid for longshore sediment transport. It will continue. We are facing a serious problem. That's why previously we thought end effect not really a problem for waves coming from the northwest quadrant, because we had only very small waves. And recent cyclones gave us a big lesson. End effect is going to be severe in the future. And most of the erosion in the recent cyclone or cyclone Taute was due to end effect, and which is net landward movement of the coastline. Can we create a stable beach? Do we need to consider only monsoon, or should we consider waves from other directions as well? Do we need to consider only the monsoon season for our coastal protection, or under climate change, should we consider 365 days? And it is more than the seasonal erosion. Now we are entering into a new phase so that we can expect waves or storms from any direction. So we should prepare for that one. To manage our coast in a most effective manner under climate change, we do need better understanding of the coastal processes and the rate of long-term sandy beach erosion. We have studied shoreline change, hindcasting. Now it's the time for us to go for forecasting under climate change, how much our beach will move onshore, further landward, which infrastructure will be affected, and how many people will be affected by that one. Not only inundation, severe erosion, or loss of land. So let me summarize my talk. Coasts are sensitive to sea level rise, which we all know, and changes in the intensity and frequency of the storms are going to affect our coast significantly. And many beaches are already in a steady recession stage, and creating a stable beach for the present and future conditions or climate change is challenging. Addressing the additional stress of climate change require a better understanding of the surf zone dynamics, not the exchange of sediments alone, where our longshore bar and how far it can move, and longshore sediment transport, which formula we should use, just an empirical formula or a spectral method. Offshore bar, we do need a better understanding about the movement of the bar offshore and onshore and its decay and interaction between the coastal structures and active sediment transport processes. We do need better understanding because of the lowering of the beach, depth is increasing. In addition to that one, there is an increase in the sea level, so double whammy effect. So we consider a stable or static seabed, all our calculations and coastal protection measures, everything based on that level. Many places, we notice that one, the beach has lowered or the near shore has lowered more than a meter because of the recent cyclones. Have we included these factors in our calculations? So water levels have strong control on the amount of erosion that occurs during storm. So not only sea level rise, the bed level decrease or the beach level lowering. We do need to have better understanding about that one. And the risk for the existing structures. Application of Bruin rule for subtropical environment may be okay with a little bit changes, but for open monsoon coast, where longshore sediment transport is dominant and longshore shoreline changes induced by variability of sediment supply is much, much larger than those resulting from sea level rise. So can coastal scientists and engineers provide a more accurate shoreline and beach loss projection due to sea level rise, land subsidence, and local factors? Thank you.
Thank you, Dr. Matthew, for the excellent presentation. I think, you have really, can I have the screen, please? So you have, really projected the challenges that we are facing in the climate change scenario. It's going to be a very tough process as we see from your presentation, and methodologies and the algorithms, the models that we use are not sufficient enough to assess the situation and come to the real predictions of the assessment of the scenarios, erosion accretion scenario, and the coastal protection strategies. So we have a couple of minutes for the a few questions. Has anybody got any questions? We can ask.
I don't see any queries in the chat box, but if anybody want to ask, you can ask directly.
Dr. Joseph.
Yes.
I have a small question. Okay, now this shoreline changes and your beach erosion, you have showed the effect of cyclones. Okay, so my question is about the terrestrial processes, because mostly these beaches are near estuaries and all. Okay, so in case of cyclones or even normal flooding, a lot of freshwater runoff goes through. So are those processes significant, or their quantification is required at this stage, or it is like more they're not are they have to be looked into it, or their effect is not significant?
Definitely, it is significant, especially the coastal barriers, barrier beaches would have significant impact on this one, because the elevation of these barriers are too low, and it is connected with the lagoon with a narrow strip. An increase in the water level there will have more impact here, then more fresh water coming, and sediment supply is very less from the rivers. And any activity there also definitely will have significant impact on the coast. Barrier island type, and particularly those parallel to the coast, which is quite a lot along the west coast of India, and these dunes or deltas on the east coast of India, low-lying deltas, definitely a significant impact on those areas as well.
Okay, thank you.
Any more? If no more questions, then I think I thank you profusely for your excellent presentation and for your time and efforts in what you call pricing us of the situation that we'll be facing in the future because of the climate change. Thank you, Dr. Matthew, and I hope you will be there for the if you have time, please do attend. You are welcome to attend the coming presentations also. We have 7 presentations following this. You are most welcome. Thank you, Dr. Matthew, once again.
Thank you, sir.
So we come to the other contributed papers. Welcome all the participants and all the other the session co-chairpersons, coordinators. It's my pleasure to welcome you all to this session. We have 7 papers that are scheduled for presentation, and I find that out of these 7, I think 5 are from the NIOT. NIOT is playing a dominant role here, and another 2. One from the IIT Madras and another one from the NPOL. So I think the rules are already set. We have got a 15 minutes time, and each contributed paper will be given 12 minutes, followed by 3 minutes of discussion. So I think we will go ahead with the strategy. And the first, can I invite the first presenter? Is he available? Sunil Kumar Mohanta from NIOT. Is he available?
Mr. Sunil, can we hear us? I think, sir, we should move ahead with the second one.
Okay, we'll move, and as soon as he reports, of course, we can schedule his presentation. The next presentation is Kirti Vasan from NIOT. Is he available?
Yes, sir.
Okay, so Kirti Vasan and co-author is Leda and Balamurugan Venkadesan. So the title of the paper is Wave Spectral Characteristics of Two Concurrent Cyclones, Kyar and Maha in the Arabian Sea. So the abstract of the paper is given in the abstract volume, page 184. So I invite Mr. Kirtivasan to make the presentations. You have 12 minutes time for the presentation. Please stick on to the time. Thank you.
Oh, okay. Sir, is my screen visible?
Yes.
Myself, Kirti Vasan, SRF from NIOT. Today I'm going to present about wave spectral characteristics of two concurrent cyclones, Kyar and Maha in Arabian Sea. Arabian Sea is a significant area of interest which has high winds and wave conditions during monsoon season. The wind direction of Arabian Sea reverses between two monsoon seasons. Summer monsoon period in southwest and in June to September, and in northeast during a winter monsoon period, October to January. The occurrence of cyclones is frequent in Bay of Bengal than Arabian Sea, but however, in recent years, the frequency of cyclones in Arabian Sea has been increased by 52%, and the number of severe cyclones has been increased by 150% between 1982 to 2019. For the first time since 1965, two cyclonic storms has been simultaneously prevailed, which are supercyclonic storm Kyar and extreme severe cyclonic storm Maha over the Arabian Sea. The cyclone Kyar is the second supercyclone to be formed after Cyclone Gonu in 2007. In 2019 only, 5 cyclones have been formed over the Arabian Sea. This growing of cyclones in Arabian Sea could be linked to global warming and could be an effect of climate change. My objective is to study the wave spectral characteristics in deep waters and during these two concurrent cyclones, supercyclonic storm Kyar and extreme severe cyclonic storm Maha in the Arabian Sea during October and November 2019, using mode void data which is deployed over the Arabian Sea in the northern Arabian Sea. And this figure shows the two tracks of cyclones and the location of our buoy data. National Institute of Ocean Technology maintains the network of mood buoys in the northern Indian Ocean, which measures surface meteorological and oceanographic data such as wind, currents, waves, temperature, and salinity. And the data from the Omni buoy, which has been used, is 8006, and which is located in 18.5 degree north and 67.5 degree east, the Arabian Sea. The wave measurements, which is obtained using a motion reference unit, which is installed in this mood buoys. This unit has 6 degrees of freedom in linear and rotational axis, measured with inbuilt accelerometers, magnetometers, and gyrosensors, in which wave parameters have been calculated, such as roll, pitch, heave, and heading. The data is sampled for 1 Hz for continuous 17-minute duration for every 3 hours. Tropical cyclone Kyar, which formed in 24th October 2019, and which is moved northeastwards and subsequently moved northwestward, and with higher intensity formed supercyclonic storm as a category 4 and reaching during when it reached maximum intensity, it was near our buoy, which is 134 kilometers away. Then after 27th October, it moved northwestward, and the intensity of cyclone decreased. The minimum sea level pressure, which is recorded, was 922 hectopascal, and wind speed was 240 kilometer per hour. The buoy observed significant wave height, HM0, which was increased from 2.06 meter to 7.38 meter. Tropical cyclone Maha, which observed, it's created on 30th October 2019, which moved northwestward and continuously forming to extreme severe cyclonic storm as a category 3. It didn't reach its maximum intensity on 2nd November when it was near our buoy, and in 4th November it reached its maximum intensity, and again it moved to eastward towards the Gujarat coast in 6th November. In both locations, the cyclone was near to our buoy with less intense period. The minimum pressure was 956 HPA and the wind speed was 185 km per hour. The significant wave height observed in our buoy was increased from 0.87 meter to 3.29 meter. The observations in our buoy data, where the pressure level was 995 HPA in Kyar and 1005 HPA in Maha. There are 2 instances the cyclone was near our buoy, and the maximum wave height was 7.38 meter in Kyar and 3.29 meter in Maha. The wave direction was related to this wind direction also. During tropical cyclone Kyar, it moved from southwest to north, south to southwestward, and it also formed same in tropical cyclone Maha and moved towards north as it came back again after crossing 2nd November to 6th November. The wind speed reached a maximum of 17.22 meter per second and 14.21 meter per second in Kyar and Maha respectively. The maximum energy density, spectral energy density, which was observed was 143 meters square per hertz in tropical cyclone Kyar and 19.28 in tropical cyclone Maha. The spectral energy density which was observed during tropical cyclone Kyar was in 24th October. It started, but the spectrum was multi-peak with swell and sea dominated. But as the cyclone moved towards our buoy and increased in intensity, this multi-peak, the energy was also increasing from 7, 10, and 40 till 26th October. And in 27th October, when it reached this maximum intensity and when it's near to our buoy around 133 kilometer, it reached a peak of 143 meter square per hertz as a single peak. And when it moved away from our buoy and the cyclone is weakening, the spectral density was also reduced and multi-peaks were also forming. When it reached 29th October, the intensity is reduced. And in 30th October, it's still reducing. But on 30th October, the tropical cyclone Maha was also formed, but it didn't have high intensity. As it moved till 2nd November, it started increasing intensity. So the spectrum was also showed the single peak and high intensity, but not much when compared to tropical cyclone Kyar, super cyclonic storm Kyar. Then after when it reaches to maximum intensity as extreme severe cyclonic storm in 4th November 2019, the intensity was not much when compared to Kyar. When again and during 6th November, it was still multi-peak, and in 6th November, it for one instance it came as single peak and in Vinci region. And again after 6th November, when the cyclone dissipated, the sea was again calm with reduced spectral energy density, with both swell and sea wave conditions, with reduced spectral intensity in the following days. This plot shows this normalized spectral energy density with time period during the in the time period which is computed for every 3-hour data. The spectral energy values normalized with respect to energy density, with peak as 1 and 0. The red dots are located at the peak frequency. So this shows the peak energy density during Kyar and energy density, peak energy density during a cyclone Maha, which is very less compared to tropical cyclone Kyar. Our Omniboy data measured the wave heights generated during the simultaneous tropical cyclones Kyar and Maha. The spectral energy density was high during tropical cyclone Kyar and fell after tropical cyclone Maha. This distance to the mooring and the cyclone was nearly same, about 135 kilometers in both the cyclones. It was nearly 135 in tropical cyclone Maha and 134 in tropical cyclone Kyar. But the intensity of the cyclone varies when it was near to the buoy location. The maximum spectral energy observed during tropical cyclone Kyar was 143 meters square per hertz, and the maximum spectral energy in tropical cyclone Maha was 19.68 meters square per hertz. The maximum wave height H max was observed as 11.13 meters in Kyar and 5.54 meters in tropical cyclone Maha. With high spectral energy density, the wind wave with high spectral energy density at wind wave frequency, the recorded wave spectra were multi-peaked and with less energy in before cyclone, and single peak with high energy density after cyclone. Thank you.
Thank you, Mr. Kirtivasan. So you have made a very good analysis about the wave spectral characteristics during the two cyclones, and have come to the conclusion about how the spectrum varies. When it is during the cyclone time, you get a single, and when it approaches, you get the multiple peak. Am I correct?
Yes, sir. Yes, sir.
Okay, it's a good work. And is there any question? Anybody wants to ask a question?
So in the chat box, there is no questions. So if anybody want, he can ask.
Okay.
Thank you.
I think we don't have much of attendance here. Not all the 7 others are present. Looks like.
Yes, sir. All are present.
All are present. Huh? Okay. So should we finish off Sunil Kumar now? If he is there, we'll
Yeah, I will try once again. He was not able to unmute himself, but I will try again.
Sunil, he has sent a message. Yeah. His problem is yet to be solved. So we'll invite Reddy. Let him solve the problem and get the problem solved. Then we will invite him. So let us invite Reddy Janaki Ram again from the NIOT. Is Reddy Janaki Ram available?
Yes, sir. Yes, sir.
Yeah, please go ahead.
I am sharing my screen. Sir, is my presentation is visible, sir?
Okay. It doesn't look like a presentation. You are make it full screen.
Yes.
Okay. Go ahead.
No. Actually, I am working in NIOT as a senior research fellow. I worked on wave spectral characteristics in shallow waters of Goa coast during pre and post monsoon seasons.
Okay.
I have analyzed the wave spectral characteristics intervalual variability, sir. For data from 2015 to 2020 during the non-monsoon season, during pre-monsoon and post-monsoon, the data was taken by moved by data from NIOT. That data I have used for generation of spectrum and separation of C and cell separation, and how a comparison of that wave spectral characteristics with other studies in Eastern Arabian Sea. Coming to introduction, actually wave characteristics will during the non-monsoon season, you can see both wind and swells are dominating. It is very important to understand the wave climate, but at a particular location, wave spectrum plays a major dominant role. A wave spectrum is a double peak spectrum during non-monsoon season. Along the west coast, apart from that double peak, we will be having a multi-peak wave spectrum with wind sea energy domination is observed along the off-west coast of Goa. Multi-peak spectrum is due to the effect of sea breeze and swells from the southern Indian Ocean. During this multi-peak spectrum, we will have the diurnal variation. Within a day, the wind direction will change rapidly and the speed will increase. And coastal locations, as you know, it is influenced by both wind and swells. To understand the wave climate at the present location, I have separated the from a normalized wave spectrum for a monthly wave spectrum. I have calculated the percentage of wind energy and swell energy by using the wave steepness method adapted by National Data Buoy Center. The objectives of the study is like interannual variability of measured spectra and separation of sea and swells from the measured spectra and comparison of wave spectral characteristics to other studies. As I said, the data in Moolboy is measured by MRU, motion reference unit, which measures the relative hue, pitch, and absolute roll. And this data is recorded at 1 Hz for every 17 minutes. For every 3 hours, we will be getting the data. And this data is processed by using fast Fourier transforms for wave spectrum generation. And the separation of sea and swells for a monthly average spectra is separated using the wave steepness method adopted by NDBC. As you can see, the wave spectrum for the pre-monsoon, February, March, April, May on the top row. If you are seeing, we will be having the double peak during the February. You can see the double peak, and similarly during the March also double peak. And as you proceed during the May, we are having the single peak domination about April because due to the southwest monsoon approach. And if you are seeing the frequency, it is every year the frequency shift is noticed during February and March also. Mostly during the pre-monsoon, sea waves are mostly dominating due to local wind, and sea waves are mostly dominating. This you can see the frequency shift in the sea waves up to 0.2. Up to 0.2 the peak frequency in sea waves. Whereas in swells, we can see the constant notation of the swells. We can see like 0.007 to 0.08 Hz, and it is noticed that long period waves are also observed during the non-monsoon season. And coming to the sea frequency, what I'm telling, the frequency shift going up to the 0.2 hertz. This shows the intra-annual variability within the year in a particular month in the same season. And coming to the post monsoon season, not like Bay of Bengal and all, because here the swell energy is more. Northeast monsoon captured here is very less, and we can see in the November the wind speed is very less, and we can see the only domination of swell. It is up to 93%. We are having the domination of swells in the November, and in December again it is multi-peaked, but swell percentage is higher. And in January you can see the multi-peak spectrum due to the sea breeze effect. And intra-annual variability is observed in October, November due to and January, February due to change in the wind direction. You can see that wind direction is changing in October, November, mostly southerly. In September, in mostly monsoon season, the wind direction is dominant in southerly direction. After October, November, the direction is changing to either northeast or southwest direction. Wind it is dominating. So there is a large change in intra-annual variability. And other thing is the wind speed in November, December is less compared with the during monsoon season and the pre-monsoon season, January, February, March. You can and that is what I noticed actually during the pre-monsoon season. We are having the 52% of sea domination, and in the transition period, May, we can see the 67% of swells are dominating. And in November, 93% of swells were noticed due to the low wind speed, and northeast monsoon contribution is low in the west coast of India off Goa. Multi-peaked wave spectrum during January is due to the sea breeze effect, wind and sea swells active from southern Indian Ocean. Sea breeze system is active during the pre-monsoon, as earlier studies noted. And if you are seeing the double peaked spectrum for the February month, there is a varying frequency between the peak energies of sea and swells between 0.08 to 0.12 hertz, and the peak spectral energy is varying from for a monthly average spectrum 0.16 to 0.85 meters square per hertz, and the average significant wave height is almost like 0.6 monthly average spectrum significant wave height, and 0.5, and the mean wave period is 5 to 6. Mostly it is between 5 to 6 seconds. And this table shows the percentage of swell and seas per seas. In this, the most dominating is in the pre-monsoon season. You can notice the seas are most dominating, and in the May you can see the swells are dominating, and in November due to low wind condition almost the swells are mostly dominating, and in January you can see due to sea breeze effect, due to local winds, we can see the seas are most dominating. And finally, you can see that in the present study, during the non-monsoon season, double peaked wave spectrum is observed, with wind seas domination during the pre-monsoon with 52%, and in month of May 67%, and November 93% swells are dominating. Multi-peaked wave spectrum in month of January due to sea breeze by local winds shows the diurnal variation and swells. During the pre-monsoon, as I said, the average significant wave height during non-monsoon season almost 0.5 to 0.6, and the mean wave period is varying between 5 to 6 seconds. These results are compared with the shallow water wave spectral characteristics along the Eastern Arabian Sea. It is in good comparison with the earlier studies. Thank you.
Okay, thank you, Mr. Janagi Rao.
Yes, thank you.
And just want to ask you a question. You observed high sea wave energy dominance in the pre-monsoon months of January, February, and March, right?
Yes, sir. Yes, sir.
So has it got any connection with the Shamal waves? You have not mentioned anything about that.
Short waves. I have not checked that, sir, actually.
Yeah, Because you have to find out, is this just local wave, or is it just local wind, or due to Shamal waves? You have to find out, because this is the time, January, February, and all that is the time of the Shamal waves. So I'm not very this one about the wave period and all those things, but that's the time of occurrence of the Shamal waves.
Okay.
So I think you can compare with the literature. Previous literature, a lot of work has been done by Vedamani and others. So, and Abu Bakr. So probably you can have a look at it, make a comparison.
Okay.
Any other question to Mr. Janakiram?
No, sir.
Okay. Okay. Thank you, Mr. Janakiram, for the good presentation.
Thank you, sir.
Okay. I think we will invite Sunil now.
Yes, sir. He's ready.
Okay. Okay. Please, Mr. Sunil Kumar.
Hello, sir.
Yes, you are. You can make your presentation now. So you are from NIOT, right?
Yes. Yes. Now it's audible, sir. My audio is audible.
Not very clear.
Okay. The sound is not very clear.
Please, you start talking, then we'll be able to respond.
Okay, sir. Okay. So now my PPT is visible to you, sir?
Yes, and make it full screen.
Yes, sir. Yes, sir. Okay.
Okay, done.
Good afternoon, everyone. Myself, Sunil Kumar Mahanto. I am a MOES research fellow working under MRFP program.
We are not. You are not audible. So can you just adjust your?
No, we will go for the. You are telling me I'm not audible. Sir, now it's audible, sir. Hello.
Okay, somewhat. Not very clear.
They are telling me very less. I'm audible very less. My audio is very less. Okay, window is open. Window, observation window. This camera audio may be selected. We check that. That is, I can remove it. You don't want camera or camera? I don't know. You don't know. No?
What's happening?
Audible?
Hello, Sunil Kumar.
Yes, sir. Is it audible, sir?
Okay, it's better. Looks to be better. Make it full screen. Your presentation, you make it full screen and start.
Okay, sir. Okay, sir. Okay, thank you. Yeah, I'm working in NIOT in Chennai.
Okay.
My topic is soundscape in summer in Kongsberg, Arctic. These are the contents of my seminar of my topic: introduction, experimental setup and location, result and discussion, and conclusion. But first, actually, what is soundscape? Soundscape is a sound or combination of sound that arises from an immersive environment. And according to soundscape ecology or acoustic ecology, soundscape are generally three types, like anthrophony, biophony, and geophony. Anthrophony includes all the sounds that generates by human being and their creation. Biophony means the sound that generated by all living organisms, that may be terrestrial or marine, but here we are considering only the marine organism. And then geophony means the sound that that produces by natural sources. This is called geophony. The soundscape of a given habitat is closely related to the sound produced by geophysical, biological, and anthropogenic sources. All these sound sources interact with each other, and they have distinct acoustic signature with temporal patterns on daily and seasonal timescale. The soundscape in Arctic Ocean is strongly influenced by geophysical sources such as ice melting as well as wind. The acoustical oceanography is showing to be a resourceful and real tool for the study of glacier ice. Urich in 1971 first acknowledged the main mechanism which actually provides the idea of melting of glacier ice produce the underwater noise. According to Urich, at the time of snow accumulation, some empty space are present in it, and as the process continues for a very long time, the number of empty space are also increases, and as the mass of the with increasing in time, the mass of the accumulated snow also increases, and as the mass increases, it will generate an internal pressure, and that internal pressure always try to reduce the volume of the accumulated snow. So the volume of the empty space present in it also decreases, and the highly pressurized air bubbles are present inside it. And due to the temperature gradient, when it melts, it generates the underwater noise. And Daichok has described three separate physical methods that involves in the ambient noise field. These are ice melting, ice calving, and freshwater discharge. Ice melting occurs in four different ways, like iceberg calving, iceberg bubbling, iceberg bobbing, and iceberg blopping. Iceberg calving means when a large section of iceberg breaking up from a ice glacier, it is called iceberg calving, and it lies in a frequency band of 0.5 kilohertz. Iceberg bubbling means the highly due to the temperature gradient, the highly when the iceberg melts, the highly pressurized air bubbles generates the underwater noise that is called iceberg bubbling, and it lies in a frequency band of 0.5 to 1.5 kilohertz. Iceberg bobbing means when an iceberg cracks and splits into small pieces, it's called iceberg bobbing, and it lies in a frequency band of less than 1 kilohertz. And then iceberg blopping means when a small piece of ice cracks from an large iceberg, it is called iceberg blopping, and it lies in a frequency band of 0.5 to 2.5 kilohertz. And the wind speed above 2 meters per second contribute in the ambient noise field during summertime, and rain noise falls in the frequency band of 0.5 to 5 kilohertz, and tipping noise falls in the frequency band of 600 hertz. Now my experimental setup and location. NIOT along with NCPOR and Government of India has installed one mooring system in the Kongsforden Port Arctic called Indian Arctic Mooring System in 2015, July 2015. That mooring system consists of so many types of instruments for the measurement of different types of parameters like CTD, conductivity, temperature, depth, then PAR, photosynthetically active radiation, SUNA. So different types of instruments are there, and along with these instruments, a pair of hydrophone are there to measure the underwater ambient noise. The hydrophone collects the underwater ambient noise in terms of voltage by detecting the change in pressure in the surrounding environment. And after when we collect the data from that system, we convert that voltage data to corresponding pressure, and for our analysis purpose, we use the P-Welch power spectral density method. There are some instruments in that mooring system generate some instrument noise actually, like PAR and SUNA. They have some self-cleaning ability, and when they clean the exterior part of their sensor, that time they generate some underwater noise. This is my details of our location. The deployment location is Kongsforden Arctic. The ocean that depth at that point is 198 meter. The sampling frequency of that hydrophone is 25 kilohertz, and sampling time is 180 seconds. Two hydrophones are used. One is situated at a depth of 40 meters from the water surface, and the second one is 45 meters from the water surface. Actually, in this analysis, I have used the summer data. So each day we have 24 data sets, because the hydrophone is working like 3 minutes, and then in a interval of 1 hour, and then again after 3 minutes it will deactivate, and then again after 1 year it will activate and collect. Like that it will work. Then so for each day 24 data sets. So for August month that is 744 data, and September that is 720 data sets. And wind data we are collecting from the Meteorological Institute of Norwegian Meteorological Institute, and ice information we are collecting from the Norwegian Ice Service, MET Norway. And the marine traffic data we are collecting from Nielsen Spot, which gives the information on the arrival and departure of the vessels. Now this one is the wind data of summer 2017, and actually we know that if the wind pressure is wind speed is more than 2 meter per second, then it will contribute in the ambient noise field, because in summer time the ice concentration is also low in Arctic, so wind speed plays an role, or it has some influence in underwater ambient noise field. This is the my 2 months spectrogram, like August and September month of spectrogram. In this spectrogram, like y-axis represents the frequency in hertz, x-axis represents the depth. Here, after analyzing the summer data, I found three separate sources, like shipping noise, ice melting noise, and rain noise. The small black ellipse represents the shipping noise, and this one represents the ice melting noise, and the red ellipse is representing the rain noise. The shipping noise is large in a frequency band of below 600 hertz. The ice melting noise is large in a frequency band of above 400 hertz, and rain noise is large in a frequency band up to 5 kilohertz. This is the spectrogram of ship noise and spectrum of ship noise. Here, if you will see in spectrum, it is a two-dimensional graph. It represents sound pressure level in y-axis and frequency in x-axis. Here, the peak of the ship noise is large in a frequency band of 200 to 400 hertz, with the sound pressure level is above 90 decibel. In spectrogram, we can see it clearly. The red color, this red color represents the frequency of the ship noise, and this is the spectrogram. It is clear actually, and this is the ice melting noise. This is the figure of ice melting noise. This is spectrogram, sound pressure in y-axis and frequency in x-axis, and the sound it lies up to a frequency of means 400 hertz to 3 kilohertz. Ice melting noise lies in between that range, and that pink color actually represents that sound frequency of ice melting noise. And its peak is almost in most of the time the peak lies in 1 kilohertz to 2 kilohertz. And then this one is the spectrum of rain noise and spectrogram of rain noise. Rain noise is generally falls in a frequency band of 0.5 kilohertz to 5 kilohertz, and this one is the spectrogram of rain noise. So in generally the sound pressure level of rain noise is less, and it is almost below 70 decibel. Yeah, that pink color actually represents the rain noise.
Please summarize.
Yes, sir. And these are the some result I have found after my analysis, like date and number of underwater noise source. Like 1st August 2017, I found 2 ice melting event and 1 shipping noise. Like that, I have wrote all that data and the conclusion. The noise level in the frequency band below 3 kilohertz have been analyzed during summer period, and from this analysis, it is clear that the underwater ambient noise during summer is strongly influenced by ice melting and shipping noise. It is observed from the summer data that iceberg is the most predominant factor during summer, and it falls in a frequency band of above 400 hertz, and shipping noise lies in a frequency band of below 600 hertz, and rain noise lies in frequency band of 500 hertz to 5 kilohertz. The continuous record of underwater ambient noise over long term will be good for our better understanding of mechanism of iceberg melting in that location. And these are my references.
Okay. Thank you, Mr. Sunil. You have
Thank you,
finished on time. So are there any questions to Mr. Sunil?
I have a question.
Okay, please go. Your
Mr.
name?
Sunil, how do you differentiate between different sound sources? I understand it is based on frequency. So have you
Yes,
ever
sir.
come across even overlapping between different sources, overlapping of frequencies?
Yeah, one two event I have seen, sir, like that. But the thing is, sir, can I
So how do you
explain?
tackle with that?
Sir, actually, intensity or sound pressure level actually it represent in spectrogram actually. It represent in color actually. So when we suppose sipping noise and melting noise, if they coincide means in same date same time if both event we detect, then that time that color intensity of the color will be changed actually. And we are using actually three separate methods. Like one is spectrum. In spectrum we can see the frequency and sound pressure level, and in spectrogram we can see like time, frequency, and the sound pressure level. And other one is the audio file, sir. From audio we can clear that whether it is a sip noise or whether it is a ice melting noise, that we can differentiate from audio file also.
Thank you.
Hello.
If I have time, I will ask one more question. Sir, Chairman.
One quick question, maybe. Yeah, please.
Okay, you can ask.
Yeah, Mr. Sunil, as you said that two frequencies are similar. So, did you check that Doppler effect or something like kind of wavelets where the ships are passing? So, you should get the Doppler effects. Is it visible? Did you see that?
I'm sir under actually till now similar frequency actually I have not I mean I did not get any data in that same frequency, but same time two data it is okay, but the frequency change, but in same frequency I have not any data till now actually. Hello.
Okay, okay, you didn't get my question anyway. Thank you. Okay, sir.
Okay, so thank you for the good presentation, Mr. Sunil.
Thank you, sir.
Can you please remove the?
Yes,
I'm still seeing your thing. Okay, okay.
Yes, yes, sir.
We have a question on YouTube.
Okay.
So can I read that?
Okay, sure. Sunil, are you there?
Yes, sir.
Okay, please.
Mahesh R. Congratulations, nice presentation. Why is it necessary to have sampling for two different depths, 40 and 45 meter? Why that depth is necessary?
Means sir, can I explain, sir? Hello, can I answer, sir?
Yeah, you may answer.
Sir, actually, in up to actually one hydrophone is in 40 meter depth from the surface, and other one is 45 meter depth, because some surface noise is up to 40 meter depth means it is mostly suitable. Other, if we will put in upper level, then some surface other noise also we can interact with that underwater ambient noise. And below that means some what else, like and two hydrophone we are using like for one different times it is working, like first one is working for 3 seconds, then it will stop, then after some time the second one will start working. So means different times data will collect, so that's why we are using two hydrophone. And the depth is for like sound to reduce the noise level. Actually we are using 40 meters depth only.
Okay, can we close that? And any more questions can be answered, later on. So let us go to the next presentation. That is from the Ocean Engineering Department, IIT, Mr. Santosh Kumar. So, Mr. Santosh Kumar, can you please make the presentation? Okay. Make it full screen. Okay. Please go ahead.
Santosh, please unmute your mic.
Yes, sir. Yes, sir. I just unmuted. A very good morning, good afternoon to all. Myself, Santosh, research scholar, working under guidance of Professor Sanasraj and Professor Murli in the Department of Ocean Engineering, IIT Madras. Today, I'm going to present on impact of future climate scenarios on fluoride ingress and carbonation levels in coastal reinforced concrete structures.
Your audio is not clear.
Is it clear, sir? Now? Hello? Sir, is it clear now?
Okay, okay, go ahead. We will tell you.
Okay, sir. It's a part of my ongoing research.
Hello.
This is the outline of my presentation, starting with introduction, factors affecting coastal infrastructure, climate scenarios, discussion on findings and need for adaptation strategies. Coming to the introduction, as a development in many countries around the world is concentrated in coastal cities, associated coastal infrastructure is very important due to the climate change induced extreme events. Coastal infrastructure is becoming more vulnerable. The climate change induced events makes the structural material to get deteriorated early and thereby reduces the service life. Reinforcement corrosion is found to be a major problem in case of coastal structures, and corrosion takes place mainly due to two major deterioration agents. They are carbonation and fluoride ingress. This climate change influences these processes, which leads to premature deterioration and thereby loss of service life and performance of any coastal infrastructure. The below images shows deterioration process of structural elements like the deck slab and column of a earthen structure. This is the deterioration mechanism chart I have prepared. I'll quickly explain about this chart. Deterioration can happen in
May I interrupt you, Santosh? May I interrupt you? Do we have any other system near you? We find a bit of reflection and all. Your voice is a bit disturbed. Is there any other system nearby? Yeah, the same thing. You know, when you are operating from two systems, there could be reflections, you know.
Sir, is my voice audible now? Hello?
Hello?
Hello? Sir, is my voice audible now?
It's okay, but not that clear, you know. Not like the earlier presentations. Okay? Please go ahead. Please go ahead.
Yes, sir. Yes, sir. Deterioration can happen in 3 ways due to aging, mainly because of usage of defective construction material or methods or lack of maintenance, and due to environmental factors or exposure conditions. Aging and environmental factors have same tools of deterioration. They are physical attack, which leads to cracking, delamination, and spalling of cover concrete by means of freeze-thaw action or erosion. Chemical attack leads to reinforcement corrosion due to chloride ingress or carbonation or sulfate attack. The corrosion then propagates through the cracks, making this an unending cycle of deterioration. When it comes to exposure conditions, it is termed as moderate, severe, and low, depending upon the elevation of the structure relative to the sea level. Apart from these, climate change directly influences environmental factors and exposure conditions, and it may alter the deterioration and accelerates it and intensifies the deterioration. Coming to the future climate scenarios, I have considered 2 parameters. They are temperature and carbon dioxide, along with the climate scenarios like RCP scenarios 4.5 and 8.5 as mentioned by IPCC. The graph of these parameters projected to the year 2100 clearly gives a warning sign, as these parameters favors the deterioration mechanism in structural elements. Apart from temperature and carbon dioxide, other atmospheric parameters like air salinity and relative humidity also affect structural elements. Chloride ions are abundant in sea environment or saline environment, and they penetrate through concrete pores. This process is called chloride ingress. Chloride induced deterioration is very common in case of coastal infrastructure, and with the increase in temperature, chloride ingress will increase rapidly. On the other hand, carbon dioxide is another atmosphere in the atmosphere leads to carbonation of the concrete, and the carbonation is high when there is ambient relative humidity, that is between 65 to 75%. Carbonation also increases with the increase in temperature and also carbon dioxide. The present study is about the investigation conducted on two berthing structures. One is at Chennai port and the other is at Cochin port. I'm also doing a long-term study on the berthing structure at Chennai port. It involves frequent check of structural health and collecting NDT measurements. NDT measurements have great importance in understanding the structure. They play a crucial role in the analysis of existing structures. Both the structures shown here were severely deteriorated. While the structure at Chennai port was constructed into the sea, the structure at Cochin port is a bit away from the sea, constructed in backwaters. Here I will explain in brief about the observations from the visual inspection of a structure. The images shown here conveys the seriousness of the problem in the present situation. It also gives a warning sign that how severe would be the problem in future due to the changing climate. The images shown here shows the corrosion activity and crack propagation. These are few images, whereas the whole structure is like it has the same problem. Chloride ingress and carbonation are two major threats to the coastal infrastructure. Chloride, as I said earlier, chloride ions penetrate through the pores of the concrete medium and accumulates on the surface of the rebar. When the chloride ions reaches a threshold limit, then it triggers a corrosion reaction. In a similar way, carbon dioxide in the atmosphere will penetrate through the concrete medium and makes the concrete medium an acidic medium. And when the pH falls below 9, the corrosion reaction will take place. This stage is called the point of initiation of corrosion or deterioration. When rebar gets corroded, it expands in size, in volume, and exerts a huge pressure on the adjacent concrete. That's how the cracks are developed in the concrete, and they propagate furthermore. And along with the cracks, the cracks will make an easy way to penetrate for the chlorides and the carbonation and the carbon dioxide. In the fourth figure, the fourth image, we can see through a crack, the rust material of corroded rebar has come out, and it can be clearly visible on the surface of the beam. And in the fifth figure, we can see a rust sample of an completely deteriorated rebar. The size or thickness of the rust material conveys clearly how much pressure it would exert on the concrete. Moving to the core part of my presentation, the temperature projections are then incorporated into the chloride ingress and carbonation models. The projections of chloride ingress levels are shown here for two regions, Chennai and Cochin. Temperature affects the diffusion of chloride ions through concrete medium. With the increase in temperature, there will be faster accumulation of chloride ions, and thereby the corrosion will take place early compared to a normal condition. The graphs here conveys for Cochin region, chloride content is found to be higher comparatively, whereas in that is for Chennai region, whereas in Cochin region, there is a diffusion of chloride ions higher. Chloride content from the present, the increase in chloride content from the present is approximately equal to threshold value of chloride ions, that is 0.6 kg per meter cube by weight of cement. Accordingly, there should be concrete depth should be increased to tolerate this in future. We can see the chloride ions how they penetrate and through the concrete medium and settle at the river. When it comes to carbonation, in the Chennai region, carbonation was found to be 0 from the measurements. But I have assumed a minimum of 5 mm to produce the graph. In case of Cochin region, the carbonation was found to be 50 mm in the present situation itself. So from the graphs, you can see there is an increase of at least 30 mm in the carbonation depth into the future, which means the concrete depth has to be increased by 30 mm at least to have a better service life and performance. These are some of the adaptation measures that are applicable to both existing as well as newly constructing structures, improvising material properties, that is better grade of concrete and steel, and construction techniques, using more corrosion resistant material in the construction. Concrete should be as less permeable as possible in order to protect from chloride ingress and carbonation. Application of corrosion resistant paint or sealers for longer life of the structure, frequent structural health monitoring and maintenance, immediate diagnosis of the deterioration or damage of the structural element. This point is to be noted because the damage has to be diagnosed. The damage or deterioration has to be diagnosed immediately. To conclude my presentation, climate change is going to have severe impact on coastal infrastructure. While the extreme events cause physical damage to the structure, changing environment can make deterioration more rapid and early. Deterioration of a structural element is like a slow poison for the structure. So the adaptation measures or strategies should be considered right from the design stage of a structure for better service life and performance. This work is part of the project titled Climate Change Impacts on Coastal Infrastructure and Adaptation Strategies, and is supported by Department of Science and Technology, India. The work is being carried out under the guidance of professors of different disciplines at IIT Madras. And thank you to Osicon 2021 for giving me the opportunity to present. Thank you, sir.
Thank you, Santosh. I just want to ask one. I am not a person from this field. I just did not understand why that carbonation level, the difference between in 2020 in Cochin you start with a higher value, whereas it is 0 at Chennai. What is that reason? Can you just tell?
Yes, sir. Yes, sir. I will tell you. In Cochin region, from the measurements, we found that the carbonation was 50 mm at that time. That can be because of relative humidity also, because the relative humidity and there is a carbon dioxide content. So those two are also the reasons for that. Whereas in case of Chennai region, we found the carbonation was nil from our measurements.
Okay.
Yes, sir. But but the same carbonation, if you see in the town or in cities away from a bit the sea, the carbonation would be very high in structures rather than chloride content.
Okay.
Because of the carbon dioxide.
Okay. Any more questions?
Sir, I have one small question. This air salinity. So, what is the relation with the rising temperatures? In the case of temperature rise, will it decrease or increase? I think, yeah.
Can I tell, sir?
Yeah, please.
Sir, actually, air salinity is different and temperature is different. Temperature will affect the chloride ions diffusion through the concrete medium. But air salinity is a medium that contains the chloride ions. That means when the air salinity is high, chloride ions is also high.
Okay. If there are no more questions, we will go to the next person. Thank you, Mr. Santosh, for the good presentation.
Thank you, sir.
I invite Janani I hope I have pronounced correctly, Janani.
Yes, sir. Yes, sir. Janani.
Okay. This is again from the NIOT. So I request you to make the presentation.
Okay.
Please upload your presentation.
Okay. Sir. Sir, is it visible, sir?
Yeah, it is. And make it full screen.
Okay. Good evening, everyone. I'm Janani from NIOT. My study is about wave spectral characteristics in deep water region in the southern Bay of Bengal. So why I have chosen this area means mostly the studies are carried out in coastal regions in both Arabian Sea and Bay of Bengal. It is more studies needed for the deep ocean studies. So I have chosen this area, and I have used the data which is deployed by NIOT in southern Bay of Bengal, that is BD14. The location is 6 degree north and 88 degree east. The depth of the water depth is 3,830 meter. And why we have to particularly study for Bay of Bengal, because nowadays the cyclones are increasing. 3 to 4 cyclones hit the Bay of Bengal comparatively than Arabian Sea, and especially for during pre-monsoon cyclones are nowadays increasing. Usually the cyclone period is for October to December, but nowadays the cyclones are occurring more in pre-monsoon season, especially in May month. So now I have analyzed the wave spectral characteristics for month-wise and season-wise during the period of 2017. So this is, I have estimated monthly averaged wave spectrum for 2017. It shows clearly that it is different from coastal regions and open ocean areas, because in coastal regions it is showing during the monsoon season double peak, but here it is showing that June, July, August, September or multi peak. So it is essential to study about the deep ocean wave spectral characteristics in Bay of Bengal also. And the highest spectral energy density is observed in month of May because of the cyclonic storm, severe cyclonic storm Mora in 2017, that is 4.86 meters square per hertz in the frequency of 0.1 hertz compared to other months. And the reports, the studies are saying that this is because of the onset of monsoon. The cyclone has happened in May. During that cyclone time, wind waves are dominates during this location. And next, seasonally averaged wave spectra was calculated. In this spectrum, it is showing that during monsoon season, it is multi-peak, and during pre and post monsoon, it is showing that double peak wave spectra. Because of the influence of both the swells and sea waves in that region. And during monsoon season, it has a high spectral energy density, that is 3.8 meters square per hertz, with the frequency of 0.06 hertz because of this monsoon time. And mostly the peaks are observed during the swell waves than the sea waves. So throughout the year. And I'm going to talk about severe cyclonic storm Mora. And the interesting thing is the distance between the cyclone formation and buoy is around 835 kilometers. Anyway, the impact is very high during this period, which is observed in our buoy, because our buoy is observed 17.17 meter per second wind speed. That is the highest wind speed over the year, which is observed by our buoy, because usually the wind is more during the southwest monsoon, but this is like during this cyclone time, it is observed that throughout the year, it is a wind speed is high during this cyclonic storm Mora. which has crossed Bangladesh coast near to that south of Chittagong. And I have analyzed during the cyclone time wave parameters. It is showing that maximum wave spectral density is observed 38.5 meters square per hertz on 30th May, because it has crossed 30th May 2017, that cyclone. So it has a high spectral energy density during that time. And maximum significant wave height is 2.24 meter, which is observed in our buoy. So anyway, the distance is fair. So even though it is observed that the highest wave, and short waves are dominates in this region. And this is for wave parameters over the period of 2017. It is observed that maximum significant wave height 3.2 meter observed during the month of June. So that is the period of southwest monsoon, and with the short period waves. So that is the sea waves which is dominating over that period. And the direction is mostly from westerly from the wave, and also the wind is from southwesterly during that year. And then I have compared this our buoy data with the WaveWatch 3 model results. It's showing that good correlation between both buoy and model results. But anyway, I have calculated error statistics for both wave parameters. It indicates that during severe extreme events, the WaveWatch data is showing something overestimating during that extreme events. Then I have concluded that because the studies are not much in deep ocean in Bay of Bengal, but only in Indian coastal waters. So it is essential to study about that wave spectral characteristics in Bay of Bengal, and model results are overestimating. So this thing I have concluded from my studies. Thank you, sir.
Thank you. You are finished?
Yes, sir.
Okay. Just one question. You have made that comparison between the model and the observed.
Yes,
so what could be that? There is an overestimation, isn't it? WaveWatch and buoy. So
yes,
what
sir.
could be the reason for the overestimate? Because
maybe the wind
I feel
yes,
that even the peak itself has shifted. Can you not see it? Because normally it's not just an overestimate alone. Even the occurrence of the peak itself, there is a shift. So, so what could be the reason? Have you thought about it?
Maybe the wind data which they have used.
Yeah, probably. Okay.
Yes, sir.
Okay, any more questions?
Can I ask one, please?
Yes, please.
You have rightly noticed the shift in the peak of the predicted and the measured one, or the hindcast one. I was wondering, they are comparing the same wave height, the buoy method and the hindcast method. Is it the same thing? Same parameter they're comparing?
Yes, sir. Sir, what is your question?
Yeah, you got my point?
No, sir.
My question. Yeah. Are you comparing the same parameters
Yes,
or
sir.
two different parameters?
Janani, are you able to clarify that? Are you?
Yes, sir. Yes, sir. I'm not to hear you, sir. Sir, yes, sir. Actually, same parameters, sir. Significant wave height.
Can you go back to the diagram?
Yes, sir. Yes, sir. Same parameters, sir. Significant wave height, which is derived from buoy and from the WaveWatch 3 model results.
Yeah, as Dr. Kurian pointed out, there's a shift in the peaks. Some time lag is there throughout.
I think you need to check your data once again, okay? And before making it, maybe I'm sure you must be going ahead with your presentations, your publication and all those things. So you need to have a real cross-check of this data, okay?
Okay, sir. Okay, sir.
Okay, Janani. Any more questions? Okay, if there are no more questions, thank you, Janani, for the good presentation.
Thank you, sir. Thank you, sir.
Okay. So next is Elizabeth Shani from NPOL. So Elizabeth Shani is there?
Yes, sir.
Okay, okay. Please go ahead with your presentation.
Okay, thank you, sir.
Can make it full screen. Oh.
Is it okay now, sir?
Yeah. Please go ahead.
Yeah, good evening all, and thanks for this platform. Myself, Elizabeth Shani, and today my topic of presentation is statistical study of seasonal underwater noise as a function of wind and traffic. My co-authors are Dr. Ninya Nair, Mr. R.P. Raju, and Dr. R. Saji. So, on to my presentation. This is the overview of my presentation. First, I will present the basics about the ambient noise and its comparison with the standard wind curve. Then I will move to the noise measurement, how I measure the noise. Then its representation in terms of the PST, that is power spectral density. Then after I will move to the variation of this ambient noise, that seasonal variation, mainly I am focusing here. Then after that, I present my model result and compare that with the seasonal variability of the ambient noise. So I'm moving to my topic. So first, just an introduction about the noise and what's ambient noise. That's only. Then ambient noise is can be it's classified into different types based on the sources. Low frequencies are mostly seismic and hydrodynamic. From that, it moved to traffic, wind, biological, and thermal noise. Here, the biological covers the wide spectrum. And here, my presentation, I'm focusing two parts of this ambient noise, that is traffic noise and wind noise. That is, one is related to the traffic and other to the wind noise. And it's statistical analysis. So the application of the ambient noise is wide. I'm not going into details of that. Just I show what's the standard reference used for the ambient noise. The standard reference used for the ambient noise is the wind spectrum. That is I'm showing here. This is the frequency versus the noise level graph, that spectrum level that expressed in the dB along y-axis. So you can see that most of the source levels, most of the sources are presented here, like hydrodynamic, traffic, wind, and thermal noise, biological noise, all are included in this standard Venn curve. But this is a very average spectrum. So most deep water cases, the ambient noise, we can use this Venn curve, but for the shallow, it will not useful. So most of the cases, deep water, we have to go for the in situ measurements. So this is about the basics of the ambient noise. Next, this is the noise measured, the measurement location, that the three locations from the west coast of India I used for the noise measurement. These are the shallow water location. So bathymetry was below 150 meters. So the measurement covered the two seasons of the location, that is summer season and the winter season. And measurement from the year 2015 to 17, I have included for this present analysis. And measurement was carried out in the INS Sargaduni, with the ship was in silent regime. Broadband omnidirectional hydrophones were used for that purpose. And 3 depth, I deployed the hydrophone, and the depth starting from the 10 to 50 meter. In order to accurately get the depth, depth sensors also were attached to the hydrophones. And the sampling frequency was 51.2 Hertz. And along with the noise data, in order to characterize the environment, we measured sound speed profile, sediment, wind data, and the marine traffic. Wind data, I used the AWS, and for the marine traffic, I used the AIS, that is Automatic Identification System. So these are about the measurement and data of my study. Next, this shows the power spectral density, but the noise expressed in terms of the dB. So this shows the typical graph. So here you can see that two red lines are here. These red lines are nothing but the Venn curves. Venn C state 6 and Venn C state 1. C state, this is nothing but it's related to the wind speed. High wind speed related to C6 6 and the low wind speed to the C state 1. PST, so here you can see that in our measured, these dotted lines are the measured levels. So our measured levels are almost near to the high sea state. That is our location being a shallow water and near to the international traffic route, our noise levels are always high than the standard reference curves. So the nearness of the international traffic routes and the ports will are the main reason for this high noise level. So next I'm moving to the, so this is just all the, this representation, I have included both the season, that is summer and winter season I have included. But in order to compare how the noise is behaves in seasonally, that is two seasons I have selected here, summer and winter. Summer season covers March, April month, and the winter season is from the December and Jan. These two months are used to represent these two seasons. So you can see this is summer season and this is winter season, and along the rows it is representing the three stations that I already mentioned. So you can see that noise measurement in winter is always higher than in the summer, and this graph shows the variability across the depth. That is, I already mentioned three depth I measured the noise. So how the noise varied across these three depths. So this higher variability means that higher length of this vertical bar, and mean and median also I imposed here. The mean is the red line and the median is the star plotted here. So you can see that variability across the depth is higher in winter, as noise level itself is higher in winter and variability also is higher in winter. And the low frequency part of the spectrum, that is low frequency part of the spectrum is mainly dominated by the traffic, and the higher frequency part of the spectrum is by the sea state condition, nothing but the wind speed. So the low frequency part of the spectrum is having the high vertical variation, that is high variability compared to the higher frequency part. And but you can see that this observation is consistent in both summer and the winter. But in case of winter, the high frequency part variability is more in winter than the summer. Summer high frequency variation is comparatively less. So these are my analysis result of the seasonal summer and the winter comparison of the ambient noise. Next, I am moving to the histogram representation and the distribution fit of the ambient noise. This is a typical figure that shows the noise level versus the probability. Here I took the histogram in terms of the probability density, and here I fixed a common x-axis, that is starting from the NL1 to NL2, just representative. I'm not mentioning the numerical values, and it is a 90 dB bandwidth. And the analysis carried out in two frequency region, that is the traffic related region that starts from the 50 to 500 Hertz, and wind related region, that is 2 to 5 kilohertz. In order to avoid the overlapping, I choose this frequency band. And the analysis also carried out in two temporal windows, that is 500 millisecond window and the 1 second window. This show the histogram representation and the distribution fit. Here this red line shows the distribution fit. Actually, I tried two types of the distribution. One is Gaussian distribution and another is the non-parametric kernel distribution. But after doing all this, I could found that the Gaussian distribution is fitting to the data. So here I am showing only the Gaussian distribution to this data. So this whole graph shows the summer and the winter. The left panel shows the summer and the right panel shows the winter. And again, this is classified into two regions, traffic region and the wind region. Using filters, I filtered these regions. Then again, traffic itself is classified into two temporal windows. That is how much length of the noise data. One is 500 millisecond, another is the 1 second data. And wind also, I similarly did the 500 millisecond and the 1 second analysis. And this shows the along the depth. This each row shows the depth. The depth start from the 10, 20, and 30 meter like that. And this is for station 1, station 2, and station 3. Now, the study result, that is the analysis of these figures, is that statical analysis I carried out in two temporal windows, 500 millisecond and the 1 second, and two spectral band, that is 500 traffic related band and the wind related band. And the Gaussian distribution is the good fit to the data. But this you can see that the Gaussian distribution is more appropriate for the wind related part than the traffic related part. And you can see that the standard deviation is more in the traffic region than the wind region. Wind region is having relatively less standard deviation. Another thing is that at temperatures,
Elizabeth, your voice is getting broken.
So, representation is sir, am I audible now?
Hello, yeah, sir? Now you are audible.
Yeah, can I continue?
Okay, go ahead.
Okay, the seasonal comparison of the analysis is that there is a change in depth-wise variation. You can see that this summer, when the depth is increasing from 10 to 30 meters, the shift in mean or median is towards the left. That is, it is shifting towards the lower energy region. So the feature is consistent in all the three stations, like station 1, station 3, and station 1, 2, and 3. But coming to the winter, you can see that as depth increases from 10 to 30 meters, the mean or the median is shifting towards the right end, that is towards the higher energy region. This is the one main feature, that is the seasonal difference I observed along the depth-wise variability of the ambient noise. And another feature is that the shift in the standard deviation. Standard deviation is also affecting by the seasonal comparison, because winter is having comparatively less standard deviation than the summer. So in order to analyze why the happen in the seasonal changes, I used the sound speed profile, that is existing sound speed profile I checked, and I used a model in order to confirm the effect of the sound speed profile on the seasonal variation of the ambient noise. And for that I used an propagation loss model, that is parabolic equation based PEIFT. And
sorry, please summarize, please.
Yeah, so in the seasonal comparison, I could see that winter there is a surface depth existing. That is, this is the January profile. So that surface depth has influenced the propagation loss. That is, propagation loss is comparatively less in the winter. So that helped in the high noise level in winter. That is low transmission loss. So that's why I'm showing here. The January is having the less TL than the May profile. So the results of my work is seasonal variation in sound speed affect the propagation condition and the noise level. Winter exhibits a high noise level and variability than the summer. Higher and the lower frequency part of the noise spectrum behaves differently in seasonal comparison. And the depth-wise variation of the noise level also shows seasonal changes. And normal distribution shows good fit to the C-state dominated spectrum, that is a winds-related spectrum. So these are the inferences of my work. And as a way ahead, I have to complete this work by including the more data from other locations. And seasonal comparison has to be completed covering the monsoon season also. So that's about the my work, and these are my references. Thank you.
Thank you, Elizabeth. That was a very interesting presentation.
Thank you,
of
sir.
course, I'm not able to interact much on this topic, but one thing, I mean, if you can just explain that the seasonal shift, you know, in the summer it is shifting towards the left, and in the winter it is shifting towards the right. Maybe due to lack of time, you couldn't properly explain. Can you just tell about that, explain about that once again?
Sir, actually, in summer, when it is moving towards a deeper depth, the noise level is decreasing.
Okay.
But in the winter, when you moving towards the depth, noise level is increasing. So in the winter, there was a duct. So that duct helped the noise, that energy to come into the deeper water, not that much deeper, but within the surface duct, it is propagating. So that duct helped the energy to come into the deeper water. But in the summer, there is no such duct was not seen. So the most of the energy, because wind-related energy and all the surface generating, so that it's not penetrating, not deep into the water.
Okay, thank you. Any more questions? If no more questions, thank you, Elizabeth, for the good presentation.
Thank you, sir. Thank you.
I invite I think the last presentation of the session, that is from Sweta Lokande, again from NIOT. Sweta is present, I believe. Please go ahead with your presentation. Sweta? Okay. We are not hearing from you. Please unmute. Sweta, what is happening? We are not hearing anything. Hello, Sharath, can you please sort it out? What is the issue?
Present. What is the problem is not sure. What's he's facing? Like, we cannot see the slides also. No.
Also, hello.
Hello, yeah.
Hello, sir. Can you hear me?
Yeah. Now
yes, now we are hearing you.
Okay, sir.
Okay.
Shall I share the screen, sir?
Yes.
Yeah, sure.
Yes, sir. Sir, is it visible?
Yes, make it full screen.
Make it full screen.
Is it visible, sir, now?
Okay, go ahead.
Yes, sir. Good evening to all of you. I am Shweta Lokhande, working as a JRF in a National Institute of Ocean Technology. So my title is Comparison of Vector Sensor Array Processing Algorithms for Underwater Source Localization. So these are the contents of my presentation. These are the introduction, then various methods for direction of arrival, laboratory experiment, then comparison of different direction of arrival estimation algorithms, then conclusion and reference. So what is first thing is, what is source localization? So source localization is a task of locating a sound source in given measurement of sound field. Sound field may be like a sound pressure or particle velocity. With these elements we will localize any source. So here I am doing the underwater source localization. So in shallow waters it will be very challenging, like in open sea environment, due to the waveguide nature of the environment, reflections, many problems will be there in the open sea environment. So for a source localization, before sensor array only used with has the only hydrophones to measure the pressure in the underwater environment. So after this, an acoustic vector sensor array can be used with measure both acoustic pressure and particle velocity, because it's a vector quantity. So it will give the three directions of the particle velocity and one pressure. So what advantage of the vector sensor array is that it provides the higher directivity with much smaller aperture when we compare to the traditional hydrophones, and it enables the estimation of range and direction of arrival with the more accuracy. So vector sensor array can be used in for the coastal surveillance applications. So this is the array coordinates, array geometry in the Cartesian coordinate system. Here we can see S is the source. So one plane wave is moving toward the horizon with wave number k, and here is the vector sensor with three elements. And IoT has developed one vector sensor array with the three elements, spacing d between the elements, and here we will determine the elevation angle, which is theta s, which can be computed in the positive z direction, and azimuth angle phi s, which can be computed from the positive x direction. So how the vector sensor array, how we can use vector sensor array for the beam forming. So these are some relations. So the acoustic pressure generated by a transmission at a single frequency can be given by this relation: PRT equals to P naught e to the power I omega t minus r, where P naught is the amplitude, or omega is the angular frequency, time, k is the wave number, and r is the position vector. And the next relation is acoustic particle velocity in terms of the acoustic pressure in the three direction, x, y, and z direction. We can give by this relationship. So the relation between acoustic acceleration and the particle velocity in three direction, x, y, z, can be given by axy is equal to del v upon del t. The accelerometer output can be converted into acoustic pressure through this equation. Here we will scale this acceleration by minus rho c upon j omega, where rho is the density of the medium, c is the speed of the light. So the output from the single vector sensor, which gives the pressure and three components of the particle velocity, can be given by x is equal to p, vx, vy, and vz. If like this n element we are using, so this can be written as x equals to x1, x2 up to xn, where small n is the number of the elements. So for locating the direction, we are using the array manifold vector. So in Cartesian coordinate system, we will use some weighing vector in order to locate the source, which the weighing vector can be given by u, theta, phi, elevation and azimuth angle, which is given by 1 cos theta, cos phi, cos theta, sin phi, and sin phi. Here for pressure term, we are using unit vector, unit weighing vector, and three terms of the particle velocity in terms of the azimuth and elevation angle. So for the ith element in terms of the pressure and velocity component can be written as wi equals to wpi, wxi, wyi, and wzi. So final weighing vector will be in this form: 1 cos theta cos phi, cos theta sin phi, and sin theta to the power jkr, where r is the position vector, k is the wave number. So data model we have used for the experiment is if there are m number of sources emit signal towards L element with a uniform linear vector sensor array. So the received signal from the vector sensor array will be in the form yt equals to summation k equals to 1 to m w theta k phi k skt plus nt, where this w is the steering vector or unmanifold vector we have calculated previously. So towards the direction, here theta k azimuth and elevation angle, skt is the signal which is emitted from the kth source, and nt with the noise vector. So there are different type of direction of arrival estimation methods are available in literature, like classical delay and sum beamformer, MEDR, conventional minimum variance beamformer, split algorithm, and music algorithm, out of which some are summarized here. First one is the conventional beamformer method. So conventional beamformer method is the simplest and non-subspace based method. The concept of this beamforming is that pointing the strongest beam in a particular direction which yields the best estimate of power arriving in that direction. So the final output power spectrum for the bearing can be given as B theta phi equals to W theta phi. Here this sign shows the transpose of the W, which is W is the weighing vector, and here X and X transpose present the density vector, which is represented by here K. So next one is the MVDR, minimum variance distortionless response. So MVDR method makes the outputting power with minimum interference and noise in the desired direction through a adjusting weighing vector W. So this is the power density spectrum of MVDR. Here we are using the inverse of the R. R is the input covariance matrix. We can be define as expectation of yt and yt h is the transport. Next one is the music algorithm. Music algorithm is a relatively simple and subspace based method. Subspace based method means it's using the eigen structure for calculating the noise subspace and the signal subspace. So we will take the eigenvalue decomposition of the correlation matrix to estimate the signal noise subspace. Once this noise subspace has been estimated, then the search for a direction is made by looking the steering vector that are orthogonal to the noise subspace as possible. So the power density spectrum for the music algorithm can be given by 1 by W theta phi transpose En. This is the noise subspace, and W theta phi. Next one is the modified music algorithm. So up to now, music algorithm is limited to the uncoherent signals. But when signals sources will be coherent or signal with low SNR, then this estimated performance of the music algorithm is deteriorate. So to remove this limitation, we have tried to improve the result in music algorithm by including a transition matrix so that transition matrix in the input result. So the new received signal matrix X will be Tj star, where J star is the complex conjugate of the original received matrix. So after this, we will to find the covariance matrix, we will add the Rx plus Ry, and then we will find the noise subspace. And this music algorithm uses the eigenvalue decomposition. So here a unified approach is presented for recovering the signal parameter for noisy from the noisy observation by using the singular value decomposition in existing algorithm. So the singular value decomposition of a matrix constructed from the observed signal data provide the key step in a robust discrimination between the desired signal and disturbing signal in terms of the signal and noise subspace. So block diagram of the modified music spectrum computation is like this. We'll input the data in time domain, then will change in the frequency domain by using the power spectral calculation. We will find the covariance matrix of this power spectral data, and after that we will add this transition matrix here, and after that Singular value decomposition method is used to find the signal subspace and noise subspace, then music spectrum computation, and the largest peak will find, and this largest peak will show the estimation of direction of arrival in terms of the azimuth and elevation angle. So for this one laboratory experiment we have performed. For development of the algorithm and fulfilling the objective for source localization, known source experiment data in acoustic test facility of NIOT is used. This experiment result present the comparison of DOA estimation of 4 methods: conventional, beamformer, MVDR, music, and modified music. So the comparison is carried out using the LEX experiment conducted in acoustic test facility for different position and different azimuth angles. So for this experiment, a signal is generated from a discrete frequency which has the range 1 kilohertz to 6 kilohertz. Each 0.5 kilohertz interval we have used, and the distance between 3 elements are used in the vector sensor array, and distance between the elements is 125 mm, and distance between the transmitter and receiver is approximately 2.5 meter. We have acquired the receiver signal by using the 12 channel data acquisition system which has the sampling frequency of 25 kilohertz. So this is the laboratory experiment setup. Here is the VSA developed by the NIOT, and here's the data acquisition system. So as I mentioned that for different positions we have calculated. So this is the receiver, this is transmitter at the position 1, base position. Then from this transmitter is moved 1.5 meter towards the north. This is position 2nd. After this, from this base again from this base location, the transmitter moved 1.5 meter toward the south. This is position 3. So these are the result for the one position, which is position 2, in which the transmitter is moved 1.5 meter towards the north direction with a frequency of 5 kilohertz analyzed, and for this actual azimuth angle is 215 degree. So these are the results of the 4 method. These are the conventional, MVDR, music, and modified music. So
Excuse me, Sweta, I think you have to wind up now. Your time is
yes sir, just yes sir, I will summarize. So now this result shows for the conventional method in terms of the resolution. We can see the accuracy of the method used. So this conventional method, here we can see the more dispersion along with this elevation but axis, vertical axis. When we have used this MVDR method, here here resolution is improved as compared to the conventional method. Then after this music algorithm, it gives the more robust and more resolution with this music method. And when we have used a modified music algorithm, it shows the highest resolution. So this is the comparison of all 4 methods. The conventional resolution was low. MVDR method, we have used the R inverse of the covariance matrix. So it is computationally more intensive than the conventional beamforming technique in terms of the error. And the music algorithm resolution improved and robust, and a modified music algorithm gives the best resolution in all the 4 methods, and it is consistent also in terms of the frequency and positions. So this is the conclusion that modified music algorithm has a better direction finding performance as compared to other method. This work is still being carried out, and for in terms of the accuracy also we are working on it. So these are the reference. Thank you very much.
Okay, thank you, Sweta.
Thank you, sir.
This work is done as part of some sponsored project.
Yes, sir. One project is going on under ministry, so for that only. And I am working here as a JRF, and this is also my PhD topic also.
So when are you completing the project? That's very interesting. That's why I'm asking you. You know,
sir, actually this is just a starting of the project. In terms of resolution only we got, but in terms of accuracy also we need to work, sir. Yes, sir.
Okay, of course, I'm not from this field. I don't understand much, but I feel that, you know.
Yes, sir. We are yes, sir. We are working on it. Yeah. Yes, sir.
Okay.
Yeah.
Any questions? Okay.
Sir, there are one question for Mr. Shani, if he's still there, in YouTube.
YouTube. Okay.
So,
Sweta, I think you don't have any questions, right, Sweta?
yeah, for Sweta, nothing. Yeah.
Okay.
Okay, sir.
So, okay, thank you, Sweta.
Thank you, sir. Thank you. Thank you very much.
Okay, thank you for the good presentation. And questions to Sunil, isn't it?
Shani, who was Elizabeth Shani? Shiny.
Shine, there is nobody like that here?
Elizabeth.
Shani. Yeah, Elizabeth Shani. Yes.
Yeah.
Okay. She's there.
Yeah.
You can read out.
From Naufal Alvi, nice presentation, Shani. Why overall noise level is higher in winter than summer in the aspect of wind? Did you get the question?
Yes, sir. Yes, sir. Can I answer that?
Yeah, please.
Sir, as you also asked the same question now, because
same question. Yeah.
Because of the existing surface vector that help the energy to reach more in that location. So, but summer we didn't have the such a vector propagation not seen in the summer sound speed profile. So that resulted in the high noise level in the winter. I think I answered that.
Okay. Let the concerned person get in touch with you if they are not happy with the answer, if they want to know something more.
Okay.
Yeah. Thank you, Elizabeth.
Thank you, sir.
So I think we have come to the close of the session, and we have been very successful in finishing the session well on time. And I'm very thankful to starting from the invited speaker to all the contributing papers. All presenters, they have done so well in maintaining the time. We didn't have to remind anybody, to stick on to the time. I'm very happy, and content-wise also, I am very happy that a very promising work is being done by the youngsters. All said and done, I'm sure that you will continue with your good work, and that will come out, because this is a forum for you to make your presentations, and you have to come out with more and more publications in the work. So that will only give you more, rewards in your career. So thank you all, and I thank Dr. Sarachandra and Supreet for assisting me and providing me all support, and for coordinating the session. I hand over the mic to the coordinators. Sarath?
Yeah. Sir, I'll just say a few words. I thank you for very effectively conducting the sessions, and so that we could finish almost on time. And I thank all the presenters, and including my colleague who has really smoothly conducted these sessions. So that's all from our side, and we can close the sessions.
Thank you, sir.
Thank you.
Thank you.
Okay.